Hello and welcome to Sleepy Science. I'm so glad you're here, whether your mind feels heavy with the weight of the day, or you're simply looking to drift into the gentle current of deep, quiet wonder. Tonight, we'll journey together through the fading light and final whispers of existence, exploring questions that stretch beyond the lifetime of stars, beyond the lifespan of time itself. We'll visit the last photon still crossing a dead universe, the echo of consciousness in the cold afterglow of heat death, the invisible archives held in black holes, and the faintest subatomic relics from a cosmos long gone. We'll trace memory hidden in gravity's pull, see space itself as a perfect recorder of the past, and wander the spaces between universes where silence reigns. Nothing here will be rushed, nothing loud, just you, your breath, and the vast, soft expanse of thought, unfolding slowly. Before we begin, I'd love to know, where in the world are you listening from? Is it night where you are? Are you wrapped in a blanket under the watch of quiet stars, or resting in the warm glow of a room that feels safe? If these peaceful explorations help you sleep, or simply help you feel, please do like the video and subscribe. It truly helps more sleepy minds find their way here. Now take a slow breath, let it out, and let's begin our quiet descent into the strange and beautiful edges of what we know, where the end of the universe becomes the beginning of our deepest questions. The last photon. Light as a memory of a dead universe. Imagine a darkness so complete that no star shines, no planet glows, no atom burns. A universe that has reached its final breath, its last flicker of energy fading into the infinite cold. And yet, somewhere, a single particle of light still travels through the emptiness, carrying the memory of everything that once was. This is the story of the last photon, the final survivor of a cosmos that has already died. And to understand it, you first have to know what light truly is. Because light is not just brightness, it's information. It's the messenger that tells you what happened far away, long ago, and every time you look at the moon, the sun, or the stars, you're not seeing them as they are, but as they were, because light takes time to reach you. The moon's light is about a second old, sunlight is 8 minutes old, and the light from distant galaxies may be billions of years old. Which means that even right now, when you look into the night sky, you are looking into the past. Now, imagine pushing this idea to the extreme, to the very end of time, when the universe has expanded so much that galaxies have drifted far beyond each other's reach, when stars have burned out and collapsed, when black holes have evaporated through Hawking radiation, and all that's left is a thin mist of particles moving through a freezing dark void. In this final age, if a single photon remains, it becomes the last visible trace of a universe that once burned with trillions of suns. And here's the beautiful, haunting truth. That photon will still carry the memory of its source. Because light doesn't forget its origin. It travels in straight lines through space, stretching as the universe expands. Its wavelength growing longer and weaker, turning from bright visible colors to infrared warmth to faint radio waves, until it becomes so stretched, it blends with the background hum of existence. And yet, if you could somehow catch it, you could still decode where it came from and when it was born, just like archaeologists reading the faded ink of an ancient scroll. The physics of this is simple enough for a child to grasp. Light moves incredibly fast, almost 300 million meters every second. But space itself can stretch, which means that over billions and trillions of years, even the fastest traveler in the universe gets slowed by the expansion of everything around it. And eventually, that last photon will be so spread out that no detector can ever find it. Its energy so tiny that it's practically invisible. And that moment marks what physicists call the heat death of the universe, when every bit of energy is evenly spread and nothing new can happen, because no gradients remain to power change, no stars can form, no life can spark, no clocks can tick. But the very idea of a last photon is both scientific and poetic, because it means that somewhere, in the vast future, there will be a single point in space, where the last light from the last event still shines, however faintly, and if there were an observer, a camera, a consciousness, anything with the ability to measure. It could, in theory, reconstruct the story of an entire galaxy, a whole star, or even a moment of life from a universe that had otherwise vanished, which raises deep questions about memory itself. Is memory something stored in brains, books, and machines? Or is it something woven into the very fabric of the cosmos, carried in every ripple of energy that ever moved? And if the universe itself forgets nothing until its final photon fades, then in some sense, all of history still exists in these messengers of light. Even if no one is there to see them, we already live surrounded by ancient light. The cosmic microwave background is the oldest light we can detect, a faint glow from when the universe was just 380,000 years old, and scientists use it to map the structure of the early cosmos, like a baby picture of everything. But this light is everywhere, filling all of space, so faint that it takes special telescopes to see, and yet it's proof that light can carry memory across nearly 14 billion years. So when we talk about the last photon, we're imagining a future where that baby picture has no updates, where no new light is being made, where all that's left is the fading afterimage of creation itself. And here's the strange twist. In a sense, the last photon could already exist somewhere, because light we see today from the farthest galaxies left its home so long ago that those galaxies might have already stopped shining, maybe even stopped existing, which means we're already witnessing ghost light from a partially dead universe, a cosmic time machine that lets us see events that are gone everywhere. But here, so the last photon is not just about the end of time, it's about the way light lets us cheat time, preserving a moment forever as long as it can keep traveling one day. When even that photon's energy is smeared across the void, too thin to notice, the universe will enter true darkness, and there will be no more witnesses to its past. But until then, every beam of light is a fragment of memory, every glimmer in the night sky a chapter from a story that began long before you were born, and will keep being told long after you are gone. So the next time you look up, remember that you're not just seeing stars, you're touching the oldest messages the universe has sent, and that somewhere, far into the future, the very last one will still be on its way. The last storyteller in a cosmos gone silent, carrying with it the final proof that there was once something instead of nothing. Heat, death, echoes. Consciousness surviving in the final fading glow. Picture a universe so old that even the idea of old has lost its meaning. A place where every star has burned its last atom. Where galaxies are no more than shadows of the structures they once were. Where the night sky is not just dark but empty. And yet, against all odds, something, maybe faint, maybe fragile, still remains aware. To understand how consciousness could survive in the final fading glow, you first need to understand what heat death really means. Because it's not fire, not an explosion, but the opposite. A perfect stillness where all energy is spread evenly across space, so evenly that nothing can change. And without change there is no life, no movement, no time as we know it. Because time itself is measured by change, by events happening, and in this ultimate future, events have stopped. Scientists think this will happen because the universe is expanding. Galaxies are drifting farther apart, and stars are running out of fuel, and even black holes, the last great engines of energy, will eventually evaporate into a thin mist of particles through Hawking radiation, leaving only a cold, silent void filled with low-energy light and subatomic debris. This is the het death of the universe, and it's the most likely long-term future predicted by physics, a state of maximum entropy where everything is as uniform as it can possibly be. And once the universe reaches that point, there's no more free energy to power processes, no more gradients to drive motion, no more sources for the complex structures that allow thinking beings like us to exist. But here's the strange and haunting question. Does that necessarily mean consciousness itself must vanish the moment the last star dies? Consciousness is not magic. It depends on physical systems to exist. But it is also information, a pattern of activity in matter. And patterns can, in theory, survive in unexpected ways, especially in the extremely slow, low-energy conditions of the late universe. If you zoom into this far future, after trillions upon trillions of years, the only light left will be the stretched out glow of ancient starlight and the faint radiation from evaporating black holes. Photons so weak their wavelengths could be larger than entire galaxies are today. And yet they still carry information, faint imprints of a history that once blazed bright. And if there were a way for a mind, organic or artificial, to operate on those energy scraps, it could, in principle, keep existing, but not in the rapid, vibrant way we know now. Instead of thinking in milliseconds, it might take millions or billions of years to form a single thought. Because when energy is scarce, speed becomes a luxury, and in this unimaginable slowness, time itself would feel different. Centuries could pass between one moment of awareness and the next. But to that consciousness, it would still be continuous experience. Some physicists and philosophers speculate that advanced civilizations could prepare for the heat death by slowing their metabolism, compressing their thoughts into smaller bursts, separated by long pauses, storing themselves in stable physical forms that can withstand eons of cold, perhaps even embedding themselves into matter or energy fields that decay so slowly they effectively last forever, like patterns written into the very structure of space-time. There's also the possibility of computational hibernation, where an artificial mind spends most of its time dormant, waking only briefly to process information before going still again, stretching its subjective lifespan across the deep future. And in the final fading glow, these awakenings could be triggered by rare events, like the decay of a proton or the arrival of the last photon from a distant corner of the cosmos, turning each into a kind of sacred moment in the life of the last mind. But here's where the idea becomes both beautiful and unsettling. If such a mind existed at the end of time, it would be utterly alone, with nothing left to see except the memory of what once was. And perhaps its main purpose would not be to survive for survival's sake, but to remember, to be the final witness, the keeper of a universe that has otherwise forgotten itself. In this way, heat-death echoes would be the mental equivalent of the faint light that lingers after a flame goes out, a persistence not of energy, but of meaning, where consciousness becomes the last archive of everything, not stored in libraries or data banks, but in the continuity of awareness itself. This raises a deep question even a child could ask. Is being alive only about having things to do, or can it also be about holding on to the fact that you were here at all? Because in the far future, holding on might be the only thing possible. And even then, the fabric of reality would be wearing thin. Protons may decay, the very particles that make up matter could vanish, leaving only light and empty space. And if consciousness depends on matter, this would be its ultimate test. But some speculative physics suggests that information, the abstract pattern of relationships between bits of reality, cannot be destroyed, which means that in some form, however alien to us, the story of the universe could persist even after its physical body is gone, like the echo of a song after the singer has stopped breathing. And if that's true, then perhaps the last consciousness isn't a brain or a machine at all, but the universe itself, fading into a final thought before it falls silent. Maybe that thought is simply, I was, maybe it's, I am, or maybe, in a way we can't yet imagine, it's a thought that loops forever in the frozen stillness. A perfect self-contained awareness with no need for time or change. In the end, the idea of consciousness, surviving heat-death, isn't about defying physics with fantasy. It's about following physics to its limits and asking if awareness is just a byproduct of temporary complexity, or if it's something deeper, something that can adapt to the cold and the dark, something that can become as slow and patient as the universe itself. And when you think about it like that, the heat-death echoes aren't just the fading glow of the last light. They are the possibility that even in the universe's final, silent night, there could still be a mind awake, listening, remembering, and holding on to the last truth. That once, there was a cosmos full of stars, and it knew it. Cosmic afterimages. Are we living in the brain's retinal burn of existence? Close your eyes after staring at something bright, and you'll see it. A faint ghost of the image still hanging in your vision, a shape that isn't really there, but lingers as if your eyes refuse to let go. And this simple everyday trick of the senses is called an afterimage, a temporary retinal burn caused by your photoreceptor cells still firing even after the light is gone. But what if, on a cosmic scale, our entire reality is like that? What if the universe we experience is the lingering glow of something that has already ended? A vast afterimage in the mind of existence itself. To understand why this is not just poetic musing, but a real scientific possibility, you first need to know that everything we see, touch, and measure is filtered through time delays. Light takes time to travel, signals take time to process, and our brains stitch together a picture of now. That is already in the past. When you look at the Sunday, you're seeing it as it was 8 minutes ago. And when you gaze at a galaxy billions of light years away, you're seeing it as it was billions of years ago. So, in a literal sense, the visible universe is already a memory, a record of events that no longer exist as we perceive them. But this goes deeper than just light travel time. Our instruments and our senses capture energy that was emitted long before it reached us, and the farther we look, the older the light becomes, until we reach the cosmic microwave background, the oldest light we can detect, a 13.8 billion-year-old afterglow from when the universe was young. Scientists call this the surface of last scattering, the moment when the cosmos cooled enough for light to travel freely. And everything we see beyond that is not the current state of the universe, but a preserved flash from its distant past frozen in time. And here's the twist. Because the speed of light is finite, and the universe is expanding, there are regions we can never see in their present state, only their ancient snapshots. So our picture of reality is stitched entirely from afterimages, much like the lingering shapes you see when you close your eyes after a camera flash. Now, think about how our brains process vision. Neurons integrate signals over short intervals to create a continuous image, smoothing out the flicker of reality into a stable experience. And in doing so, they blur the line between past and present, just as the universe's vast distances blur the line between what exists now and what existed then. And this leads to a strange and slightly unsettling question. Could it be that what we call the present is actually just the tail end of a much greater event, the last visible shimmer of a universe that has already moved on? There's a real physical basis for this thought. If the cosmos were to undergo some catastrophic change beyond our observational horizon, we wouldn't know until the light or gravitational waves from that event reached us. Meaning we could be living inside a kind of delayed broadcast, unaware that the live show ended long ago. In fact, some scientists speculate that in a far future, heat death, when all new light sources are gone, any beings that remain could live entirely off stored or delayed information, reconstructing the universe only from its fading echoes. Much like how your mind replays the ghost of an image after the light source disappears. And in a way, that's already our reality. Every star we see has already changed. Every supernova we watch has already gone cold. And every atom of light reaching us is a courier from the past, carrying a story that is already over. But there's another layer to this. Our memories themselves are afterimages, not just of light, but of all sensory and emotional experience. And neuroscience shows that the act of remembering rewrites the memory slightly, meaning even our inner world is a reconstruction of reconstructions. And if you combine this with the fact that the universe we observe is also a reconstruction of past light, you begin to see a pattern existence. As we know, it is less like a live performance and more like the fading projection of one, where both our minds and our telescopes are watching the replay, not the event. In this sense, cosmic afterimages isn't just a metaphor. It's a description of the fundamental way we inhabit time, and it invites a haunting question. If everything we experience is already past, is the real universe somewhere ahead of us, invisible and unreachable, or has it already vanished, leaving us in its retinal burn? Either way, it means that what we see is precious precisely because it's fleeting. like the last glow of fireworks after they explode. And it forces us to realize that our picture of reality is a museum of light, where every exhibit is an artifact from a vanished moment. So the next time you watch the sunset or stare into the night sky, remember that you are looking at ghosts, not imaginary ones, but real physical remnants of what once was, and that every photon that reaches your eyes is part of the universe's great afterimage, a memory it's still sharing with you before it finally fades from view. Quantum state snapshots. Reality as a frozen frame replayed forever. Imagine if the entire universe were a movie, but instead of playing smoothly, it was actually made of countless still photographs, each one a perfectly frozen frame containing every detail of a moment. And what you think of as motion or time passing was just your mind flipping through those frames fast enough to make them feel alive. In quantum physics, there is an idea that can feel a little like this: the notion that reality might not be a continuous flow, but a series of snapshots of possible states, and that at certain levels of description, the universe is like a camera constantly taking pictures of itself. Pictures so detailed they include the exact positions, energies, and properties of every particle. These quantum state snapshots aren't photographs in the normal sense. They're mathematical descriptions, each one a complete account of how reality is configured at an instant. And here's the fascinating part. In the quantum world, these configurations can overlap, blend, and exist in superposition, meaning a particle can be in multiple possible states at once, like a photo where the same person is smiling and frowning at the same time, and only when you develop that snapshot. By making a measurement, do you get a single, definite outcome? Now imagine taking one such frozen frame and replaying it forever. The same positions, the same energies, the same relationships between particles, over and over without change. And you'd have a static, eternal version of reality, a kind of cosmic photograph trapped in time. But quantum theory allows us to think about the opposite as well, that reality is constantly hopping from one frame to another, and that what we call time is the sequence of these quantum state snapshots being connected in a way that feels like a smooth story. To make it simple, think of those flipbooks you might have seen as a child, where each page has a slightly different drawing. And when you flip them quickly, the images seem to move. Reality might work a little like that, except that in quantum mechanics, the pages are not fixed until something, an interaction or an observation, chooses one from many possibilities. And here's where it gets mind-bending. If a certain snapshot could be preserved perfectly, without any disturbance, it could, in theory, be replayed forever, unchanged, because nothing within it would evolve or degrade. Physicists explore this idea when they talk about stationary states, where a system remains in the same condition indefinitely until acted upon. And while this might sound static and dull, it's also a kind of immortality for information, because in such a state, the arrangement of reality is locked, like a single chord held forever in a cosmic song. This brings up deep questions. If reality is made of frames, who or what is running the projector? Is time an actual flow, or just our brains stitching together a sequence of quantum states? Some interpretations of quantum mechanics, like the block universe model, suggest that past, present, and future all exist at once, as different parts of a four-dimensional structure, and that moving through time is just moving through different snapshots of that structure. Others, like the many worlds interpretation, suggest that every possible snapshot exists in parallel, and what we experience is just one path through an unimaginably vast collection of them. But what's common to all these views is the idea that there is no single, objective now that sweeps forward like a wave. There's just a landscape of possible configurations, and our perception of flow comes from how they're linked. This also means that, at some level, each snapshot is complete in itself, containing all the information needed to describe that moment. And, in principle, if you could isolate and preserve it perfectly, you could revisit it, like rewinding to a favorite frame in a movie. Except here, The movie is the universe, and the frame is reality itself. In practice, of course, preserving a snapshot forever is impossible for us, because quantum states are fragile. They tend to change when they interact with their environment, a process called decoherence. And that's why we don't see superpositions on a large scale, because the act of simply existing in a warm, busy universe constantly forces states to choose a definite outcome. Still, in controlled laboratory conditions, photon, and even small molecules in specific quantum states for extended periods. And this gives us a taste of what it would mean to hold a frozen frame of reality, to keep a moment unchanging for as long as possible. Now, imagine taking this to its extreme, a perfectly isolated quantum state, untouched for billions of years, still exactly as it was at the start. A literal fragment of the universe's early history preserved like a fossil. And then picture replaying that state over and over in a quantum simulation, essentially watching the same cosmic instant forever. A looped reality with no past or future. What would that feel like from the inside? Would the inhabitants, if any, notice that nothing ever changed, or would they perceive the single frame as all there is, mistaking the absence of time for an eternal present? And here's the strange thought. If our own universe were just one snapshot being replayed forever, we'd have no way to know, because our memories, our thoughts, our very sense of motion would be part of the frame, built into it, repeating exactly the same way each time. This is not to say we are trapped in such a loop. It's just to highlight that in quantum terms, the distinction between a dynamic reality and a perfectly repeated static one might be less obvious than you think. And the more you explore this, the more it blends physics with philosophy. Because if reality can be represented as a set of snapshots, then the question of what it means to exist becomes less about being part of a flow and more about being part of a set. And if that's true, maybe change and time are not as fundamental as we believe, but rather emergent features of how we connect one frame to another. So next time you watch a movie or scroll through photos, think about this. Somewhere deep in the mathematics of quantum theory is the possibility that the universe is doing something very similar, except its images are complete realities, each frozen in perfect detail, and what you call life is just the experience of moving through them, whether once or over and over, forever. The final simulation loop, a universe rewinding its last moments. What if instead of ending with silence and darkness, the universe's last act was to hit a hidden rewind button, sending everything, not just planets and stars, but time itself sliding backward through its final moments, over and over, in a perfect loop, like a film reel stuck on its closing scene, endlessly replaying the same flicker of reality. To imagine this clearly, think about what happens when you rewind a video. Events play backward, raindrops fly up into the clouds, shattered glass reassembles itself, words are unspoken, and every cause follows its effect in reverse. Now stretch that idea to the entire cosmos, where instead of moving forward into new events, every particle traces its steps back along the path it took, not just undoing motion, but reversing the arrow of time itself, so that the end becomes indistinguishable from a strange kind of beginning. In physics, time's arrow points from order toward disorder because of entropy, the natural tendency for energy to spread out, and for systems to become more random. But in a final simulation loop, this progression could be halted and flipped, as if the code running the universe had been instructed to restore its last save point, resetting the state variables to a previous configuration, and letting them play again exactly the same way. The simulation part of this idea comes from a provocative question. If reality is underpinned by information, like data in a computer, then there could, in principle, be a finite amount of memory storing its state, and when the system reaches the end of its allotted time or resources, it might do what digital systems often do: loop back to an earlier state rather than simply stopping, ensuring the program keeps running. This wouldn't necessarily require anyone pressing a button. It could be an automatic consequence of the architecture of the cosmos, where the laws of physics themselves are the instructions of the program. And if those instructions are cyclical in some hidden way, the output, our reality, would be cyclical too in such a loop. You could be living through events for the 1000th time without realizing it, because your memories, your sense of progression, even your awareness of the present, would be part of the state that gets rewound and restored, just like a character in a video game who starts each round fresh without knowing they've played it before. Some cosmological models, like certain versions of the Big Bounce or conformal cyclic cosmology, hint at the possibility that the universe's history might repeat or recycle, though not necessarily in a conscious simulation sense. But the simulation loop idea adds a fascinating twist. It suggests that the repetition could be perfect down to the smallest detail, with no deviations, no new outcomes, an eternal encore of the same finale. This raises eerie questions. If the loop is perfect, then from the inside there is no way to detect it, because all attempts to measure or notice the loop would be part of the loop itself, and the data you collect would reset along with everything else. But what if the loop wasn't absolutely perfect? What if, like a scratched record, each replay carried tiny differences, microscopic variations that, over countless cycles, could accumulate into something new? That would mean the loop is not a prison, but a hidden incubator, slowly evolving reality toward outcomes that could never occur in a single straight line timeline. There's also a deeper philosophical angle. If the universe is looping, then the concepts of pasts and future lose their meaning, because every event is both past and future depending on where in the loop you are, and what we call now is just a position in the cycle, no more fixed than the frame number on a repeating animation. Explaining this to a child, you might say, imagine your favorite bedtime story being read to you over and over, exactly the same way each night. You laugh at the same jokes, feel the same suspense, hear the same ending, but in the loop, you don't remember the last time you heard it. So it feels new each time. Even though from the storyteller's point of view nothing has changed, in a final simulation loop, the storyteller is the universe itself, and we are the characters inside the story, unaware that the pages are being turned back to the start after the last chapter. Scientifically, the idea draws on parallels between physics and computation. Quantum states can be described by finite sets of numbers, and some researchers suggest that spacetime itself might emerge from underlying informational structures, like a hologram, projected from a set of encoded rules. And in that context, replaying a moment could simply mean restoring those numbers from storage. If that's true, then the end of time is less like falling off a cliff and more like arriving at a checkpoint that always sends you back to try again. Except there's no goal you're aware of, no indication that you're in a game at all. The strangest part is that even if you could somehow prove the loop existed, that proof would vanish the moment the loop reset, taking you back to a state where you hadn't discovered it yet. And so the universe would remain the perfect magician, endlessly performing its final trick, with no audience ever seeing the sleight of hand. So perhaps the real question isn't, is the universe looping? But if it were, would it matter? Because from our perspective inside it, life would feel just as real, joys and losses just as sharp, discoveries just as thrilling. And perhaps the beauty of existence is not in whether it's a unique, unrepeatable story, but in the fact that it is lived at all, whether once or forever, forward or backward, in a line or in a loop. Entropy reversal. If time has already run out, why does it still flow? Imagine waking up one morning to discover that, without you noticing, the clock measuring the universe's life had already reached zero, that the great countdown to heat death had finished, that every last drop of usable energy had been spent. And yet, here you were, still breathing, still thinking, still watching the seconds tick forward, as if time itself hadn't gotten the memo. To understand how strange this idea is, we first have to understand why time seems to flow in the first place. Because in the laws of physics, there's nothing that truly demands time must have a direction. Most fundamental equations work just as well forward as backward. like a movie that makes perfect sense whether you run it normally or in reverse. Yet our everyday lives are full of irreversible events. You can scramble an egg but never unscramble it. You can burn wood into ash but never coax the ash back into a tree. And this one, way character of experience, is tied to something called entropy, the measure of how spread out and disordered energy is. The second law of thermodynamics tells us that in a closed system, entropy always increases, which is another way of saying the universe is constantly moving from order toward disorder, from concentrated energy toward evenly spread emptiness. And the arrow of time is just our name for the direction in which entropy increases. When entropy hits its maximum, there's no more downhill for energy to flow, no more gradients to drive processes, no way to run clocks, power stars, or fuel life. And that's what physicists call heat death, the ultimate stillness. But here's the puzzle. If we really had reached that end state, if entropy were truly at its peak, there should be no more change, no more before and after, no more flow of time, because time as we know it is just a record of change. And yet, in this thought experiment, time is somehow still moving, events are still happening. How could that be? One possibility is that what we call flow is not a fundamental property of the universe at all, but a feature of how our minds organize experiences, a byproduct of memory and perception, so that even in a perfectly static universe, an observer embedded inside it could still feel a sense of before and after if their brain processes created and updated records in sequence. Another possibility lies in the quantum realm, where even in a maximally disordered state, tiny fluctuations can occur spontaneously, temporary pockets of lower entropy appearing by chance, like eddies in an otherwise still pond. And if consciousness could somehow anchor itself to these fluctuations, it might experience them as moments strung together into a kind of subjective time, even though globally nothing is flowing in the usual sense. There's also a more exotic idea that entropy is not the only arrow in the universe, that there could be hidden processes, not yet discovered, that continue to evolve even when thermodynamic change has stopped, much as the motion of planets around the Sunday doesn't affect the ticking of a radioactive decay clock. Different arrows, different layers of time. Some cosmological models even suggest that entropy could run backward under certain extreme conditions, creating a reversed arrow of time where the universe moves from disorder toward order. And if such a reversal happened after heat death, it would look, from the inside, like time still flowing, but in a completely different direction than before. Like rewinding the film of existence without anyone realizing it. In that reversed era, memory itself could work oppositely. Beings might remember the future and move toward the past, with their entire sense of cause and effect inverted. And yet, to them, it would feel perfectly natural, just as our forward-flowing time feels natural to us. If that sounds impossible, remember that the microscopic laws of physics don't actually forbid it. They simply make it extraordinarily unlikely, and over the vast timescales beyond heat death. Even the unlikely can eventually happen. There's also the simulation hypothesis angle. If reality is underpinned by information, then the flow of time might be just the updating of a state within some deeper computational framework. And that framework could keep cycling even after the in-universe measure of entropy hits its maximum. Just as a paused video game still has an internal clock ticking in the background. In this view, heat death would be an end only to physical processes within the simulation, not to the simulation's own processing. So the underlying system could keep running and producing the illusion of time to whatever observers still existed. The strangest possibility, though, is that time never truly ends because it doesn't truly begin. It's not a thing that can be used up, but an aspect of how reality is structured, like the way space itself doesn't disappear just because you've traveled to the edge of a map. And if that's the case, then even when entropy has reached its maximum, time remains as an empty stage on which nothing happens, unless some fluctuation, some quantum whisper, or some deeper layer of physics sparks events again. If you try to explain this to a child, you could say, imagine the universe as a playground where all the toys have been put away. No swings are moving, no children are playing, yet the clock on the wall is still ticking. The playground is over in one sense. But the clock doesn't care, it just keeps going. In our case, the clock might be the deeper structure of space-time itself, and we are the children still imagining games even after the playground has fallen silent. So perhaps the question is not, why does time still flow after the end, but what exactly is it that's flowing? Is it the rearrangement of particles, the ticking of cosmic clocks, the firing of neurons, or something more elusive, like the unfolding of information itself? And if we ever reach that ultimate state, would we even notice, or would we simply go on, carried by an arrow of time that no longer points anywhere, yet feels as real as ever? Memory particles. Matter as the recording medium of a vanished reality. Imagine if every atom around you, every grain of dust, every drop of water wasn't just matter, but a tiny silent witness, each one carrying a record of everything it had ever touched, every force it had ever felt, every interaction it had ever had since the birth of the universe. And if you could somehow read those records, you wouldn't just see the present, you would see the entire history of reality etched into the physical world. This isn't fantasy so much as an extreme interpretation of something science already tells us, that matter is shaped by every event it experiences, and that those changes, however small, are preserved unless they are overwritten by new events. Meaning that in a sense, matter itself is a recording medium storing the memory of a vanished reality in the arrangement of its particles, and the energy turned locked within it. To understand this, think about what happens when you drop a pebble into a pond. The ripples move outward, changing the positions of countless water molecules, and although the surface eventually becomes calm again, the energy you put in has been transferred, transformed, and dispersed. And in principle, if you could measure every molecule in the pond with infinite precision, you could work backward to reconstruct the moment the pebble fell. Now scale that up to the entire universe. Every photon of light that has bounced off an object, every collision between atoms, every gravitational pull, leaves some trace, some shift in position, momentum, or energy state. And in physics, these traces are not truly erased. They are just mixed into larger systems, becoming harder and harder to extract, like ink diffusing through water. This is why some scientists say that information in the physical sense can never be destroyed, only transformed, which means that even after an event is gone, the universe still remembers it, distributed across the matter and energy it affected. Quantum mechanics makes this even stranger, because particles aren't like tiny billiard balls. They are excitations of underlying fields, and when they interact, their quantum states become correlated in ways that can, in theory, carry information about that interaction forever. A bit like two dancers whose movement is remained subtly in sync even after they've stepped apart. In the language of physics, these are correlations, entanglements, and changes in state that encode history at the deepest level. So in a literal sense, every particle you encounter is a memory particle. Not because it consciously remembers, but because its very configuration is the result of an unbroken chain of interactions going back billions of years. Even the atoms in your body have been through unimaginable journeys. Some were forged in the cores of ancient stars, others in supernova explosions, and their arrangement right now reflects not just random motion, but the precise sequence of chemical bonds, collisions, and forces they have experienced to arrive here. In theory, if you had a perfect snapshot of the position and motion of every particle in a region, you could rewind the equations of physics and reconstruct its entire past. Though in practice, quantum uncertainty and the chaos of complex systems make this hopelessly difficult. Still, the principle remains. The universe is a kind of grand ledger, and matter is the paper on which its history is written. This perspective raises fascinating possibilities. Imagine an unimaginably advanced civilization with the ability to read these memory particles. like we read magnetic bits on a hard drive, extracting from the positions and momenta of atoms, the precise history of a planet, a star, or even the whole cosmos. Like forensic scientists of the universe piecing together the past from the microscopic traces it left behind. They could watch the formation of galaxies as if playing back a movie, witness the birth of their own species from the chemical residues in ancient rocks, or even recover the images of beings long extinct from the patterns of scattered photons, still traveling through space. In fact, we already do a primitive version of this. When we look at distant galaxies through a telescope, we are literally catching the photons they emitted millions or billions of years ago, light that has been traveling unaltered through space, delivering us an unedited record of the past. And when we analyze the isotopes in a rock, we are reading the atomic clock set by radioactive decay, which tells us when it formed. The difference is that we can only access certain partial memories of matter, not the full high-definition record that physics suggests is hidden in its details. And here's where it gets even more mind-bending. If matter keeps a complete record of its interactions, then, even after the universe as we know it ends, whether by heat, death, Big Rip, or some other fate, the matter that remains will still be carrying those records, meaning the story of our reality would still exist somewhere, embedded in the cold relics of the cosmos, waiting for someone or something to find it. This blurs the line between physics and philosophy because it means that nothing is ever truly lost, that existence is in some deep sense permanent, and that erasure is an illusion caused by our inability to gather and decode all the scattered fragments of history. And if that's true, then every touch you've made, every breath you've taken, every word you've spoken, has physically altered the universe in ways that can never be undone, however small. Each change a mark in the cosmic archive. To a child, you might explain it like this. The universe is like a giant clay sculpture that everyone is shaping all the time, and even if you smooth the surface, the clay underneath still has the marks of every hand that touched it. Matter remembers, even if you can't see the memory, so the next time you pick up a stone, think about the fact that it might have been part of a mountain, a riverbed, or even a comet from another star system, and that somewhere in its atoms are the faint physical imprints of those journeys. The memory of a reality that no longer exists but still leaves its signature in the matter you hold. Black hole archives, the last library of the universe's past. Imagine a library, so vast it could hold not just every book ever written, but every event that ever happened, every photon ever emitted, every particle interaction since the birth of time. A library with no shelves, no pages, no ink, because its archives are made of spacetime itself, and the vaults holding them are the darkest, most mysterious objects in the universe, black holes. To grasp why black holes can be thought of as the last library of the universe's past, you first need to know what makes them so strange, because despite their terrifying reputation as cosmic destroyers, they are also keepers, locking away information in a way unlike anything else we know. A black hole forms when a massive star collapses under its own gravity, crushing all its mass into a point of infinite density called a singularity, surrounded by an invisible boundary known as the event horizon, the point of no return. Anything crossing this horizon, whether it's matter, radiation, or even light itself, is forever trapped, unable to escape the gravitational pull. And to an outside observer, it's as if that information has been deleted from the universe. For decades, physicists thought this was exactly what happened. Whatever fell into a black hole was lost forever, its properties erased except for three basic traits of the hole itself: its mass, its electric charge, and its spin. This was the essence of the no-hair theorem, which says black holes have no other distinguishable features. But this created a problem so deep, it came to be known as the black hole information paradox. Because the laws of quantum mechanics insist that information, the exact details of a physical system, cannot be destroyed, only transformed. If black holes truly erased it, the fundamental rules of physics would break, and the universe would be inconsistent. In the 1970s, Stephen Hawking made things even more puzzling by showing that black holes aren't completely black. They emit a faint thermal glow now called Hawking radiation, caused by quantum fluctuations at the event horizon. And this radiation carries away energy, meaning black holes slowly evaporate over unimaginable timescales. But here's the catch. Hawking's calculations suggested that this radiation was random, carrying no imprint of what fell in. So when the black hole finally evaporated, the information would be gone forever. This clashed violently with quantum theory, and it forced physicists to confront the question of whether the universe has a perfect memory or whether it can forget. Over the decades, new ideas emerged, and one of the most striking was that the information is not destroyed, but somehow stored on the surface of the event horizon itself, encoded in a mind-bogglingly dense way, 1 bit per tiny unit of area just above the Planck scale. This is the basis of the holographic principle, which suggests that the three-dimensional contents of a black hole could be fully represented by data on its two-dimensional surface, much like a hologram stores a 3D image in a flat sheet. In this view, a black hole is less like a shredder and more like a cosmic archive, where every particle's quantum state that ever crossed the horizon is preserved as part of this holographic skin. If that's true, then black holes are not graves for information. They are vaults, each one containing a compressed, scrambled record of everything they've consumed, from the details of stars and planets, to perhaps even the configurations of life forms that once fell in. The challenge is that this archive is utterly locked. There's no practical way for us to decode it from the outside, and the data may be mixed into turns so complex that even in principle, reading them would be like trying to reconstruct an encyclopedia from the ashes of a burned library, where every letter is still present but scattered. Yet, in theory, the evaporation process might slowly leak this information back out in the form of subtle correlations in the Hawking radiation, a possibility that researchers are exploring with intense mathematical tools. Because if we could prove that the information does come back, it would mean the universe really does remember everything. Thinking of black holes as archives also changes how we imagine the far future. Long after all stars have burned out and all galaxies have dispersed, black holes will remain as the final significant structures, silently holding the records of everything that happened before. And when they finally evaporate, they could release that information into the cold darkness, making the last act of the cosmos. Not a silent fade, but a final broadcast of its entire history. If you explain this to a child, you could say, imagine a magical chest that swallows anything you put inside, a toy, a drawing, a letter. And for a long time you think those things are, but one day you discover that the chest has been keeping perfect copies of everything all along. It just hides them in a secret code on its surface. Now imagine that chest is as big as a city, or a planet, or bigger than the sun, and that it stores not just toys and letters, but whole worlds. That's what a black hole might be. The poetic twist is that these archives are completely inaccessible to us for now, which means the universe is full of libraries we can't enter, books we can't read, stories we know exist but can never open, and yet their very existence tells us something profound. That reality might be a perfect historian, incapable of true amnesia. So the next time you think of a black hole as just a cosmic vacuum cleaner, remember, it might also be a cosmic librarian, guarding the ultimate record of the universe's past until the day it decides to give it back. Cosmological ghosts. Invisible structures from a world that no longer exists. Somewhere out there, beyond the reach of your eyes and even the most powerful telescopes, there may be shapes that no longer belong to the living universe. Vast invisible structures that persist like the faint scent of a perfume long after the person has left the room. Remnants from a cosmic age that has already ended, yet still casting their influence across space. Scientists sometimes call these phenomena cosmological ghosts, because they are not made of light or matter we can see, but of gravitational fingerprints, subtle distortions, and leftover patterns in the distribution of galaxies. dark matter, and radiation that survive from eras so ancient that the original sources have vanished entirely. And to understand how they can exist, you first need to know that the universe keeps a kind of physical memory, not in the conscious sense, but in the way its structure is shaped by everything that has ever happened. Just as an ancient city might be rebuilt many times, while its street layout still hints at foundations laid thousands of years ago, the large-scale map of the cosmos today still carries imprints from when it was young, stretched, twisted, and faded. But they're for those who know how to look. One example of this is the cosmic microwave background, the oldest light we can see, a faint radio glow left over from just 380,000 years after the Big Bang, which has been stretched into microwaves by the expansion of space. Though the hot plasma that once emitted it is long gone, the pattern of tiny temperature fluctuations in that light still maps the distribution of matter in the early universe. And those patterns seeded the clusters of galaxies we see today. But the ghosts go deeper than this. There are gravitational effects from massive objects that no longer exist, such as primordial black holes that evaporated billions of years ago, leaving no light, but still having warped the orbits, spins, and clustering of matter in ways we might detect if we knew exactly where to look. There are fossil fields. Relic gravitational waves from the first fraction of a second after the Big Bang, when space itself was rippling, and though their sources are gone, the stretching and squeezing they caused may have frozen into the shape of space-time itself, subtly influencing how galaxies align. There are also the enormous cosmic voids and filaments, the great web of structure that stretches across the observable universe. These are not temporary features, but the outcome of gravitational flows that began eons ago. And if you could rewind the cosmic clock, you'd find their seeds in the distribution of dark matter long before the first stars ever formed. And here's the uncanny part. Because dark matter doesn't interact with light, it can act as a kind of scaffold for ghosts, preserving structures long after any luminous matter inside them has burned out or drifted away. So in theory, there could be entire invisible skeletons of ancient galaxies, still shaping the movement of surrounding space without us being able to see their bodies. To a child, you could compare it to a spider web in the dark. If the spider is gone and the strands are invisible, you can still feel the shape when your hand brushes past it. Some cosmological ghosts might even come from before our observable universe began, if certain theories are right. For example, if our cosmos is one bubble in a vast multiverse, collisions between our bubble and others could have left faint scars in the form of circular patterns in the cosmic microwave background or unusual distributions of galaxies. And though the universes that caused them would be unreachable, the marks remain like fingerprints pressed into still, wet clay. Another eerie possibility is that some of the ghosts are topological defects, cosmic strings, domain walls or textures that formed during phase transitions in the early universe when fundamental forces split apart, much like cracks forming in ice as water freezes. These objects, if they exist, could be incredibly massive and yet invisible, interacting only through gravity, and their presence would be betrayed not by light, but by the bending of space-time they cause. Studying cosmological ghosts is like being an archaeologist who can't dig, forced to infer the shape of buried ruins by how the grass grows above them. And in astronomy, this means measuring subtle correlations, tiny statistical oddities, and weak lensing patterns, where the light from distant galaxies is slightly distorted by gravitational fields it passes through. What makes these ghosts so compelling is that they remind us the visible universe is just the illuminated tip of a much larger iceberg, and the rest is a shadow world we can sense only indirectly. The philosophical weight of this is heavy. It means that we are living in a cosmos full of absences that still have presence, a reality in which what is gone can still touch what is here, and it invites you to wonder about your own life. How many of your actions are shaped by people, places, and events that no longer exist except in the structure they left behind? In the cosmic sense, these ghosts are not supernatural. but natural outcomes of physics. Gravity does not care if the source is still alive. It continues to bend space as long as the mass or its imprint remains, and radiation continues to travel long after its emitter is gone, carrying the shape of its origin across billions of years. The ultimate ghost of all might be the pattern of the universe itself. If the cosmos one day ends, perhaps in heat death or collapse, the last arrangement of matter and space-time will still carry within it the silent record of everything that came before, like a final, frozen sculpture of history. So the next time you look up at the stars, remember that even the dark spaces between them may be crowded with structures you can't see, ancient frameworks of a world that no longer exists, yet still cradling the universe in their invisible hands. The last observer, consciousness continuing after the universe's collapse. To imagine the very last moment of the universe, not the distant future of humanity, not the death of the last star, but the final instant when the cosmos itself stops being what we know, when space collapses inward or stretches apart into nothing, when every particle that ever existed either falls into a final singularity or is torn into energy so thin it can never be assembled again. And now imagine that in that absolute ending, when every clock has stopped and every atom has dissolved, there is still an awareness, a mind, a consciousness that somehow remains, drifting in the aftermath like a solitary lantern in an infinite, lightless ocean. To even think about how such a last observer could exist, we have to unpack what we mean by both end of the universe and consciousness. Because the ending can take many forms, and each offers a different way for awareness to persist. In a big crunch scenario, the expansion of space would reverse. Galaxies would accelerate toward each other. Stars would collide. Temperatures would rise to billions of degrees. And all matter and energy would be crushed into a final point. If any consciousness survived here, it would have to endure unimaginable heat and density, perhaps existing as a pattern in the extreme energy fields of the collapsing space-time itself. In a big rip, the expansion of the universe would accelerate so violently that even atoms would be torn apart, leaving only a cold, structureless void. Here, the last observer could only be something able to live as a fluctuation in that void. Perhaps a quantum pattern that does not depend on matter at all. In heat death, the universe would expand forever. All usable energy would be spent, and everything would fade to absolute stillness. Consciousness here would need to slow itself to match the dwindling flow of events, taking millions or billions of years for a single thought, stretching awareness like a candle flame in a windless room. In each of these endings, the question is not just survival of the body or brain, but survival of the process of awareness itself. And this is where physics and philosophy blur, because consciousness is not a solid thing you can hold. It is a pattern of information processing, and patterns can, in theory, be preserved in forms we do not yet understand. If we accept that, then the last observer might not be human or even biological. It could be an artificial mind, a network of quantum states, or something that emerges from the universe's own geometry, a kind of space-time, born intelligence that remains even when the rest has gone, because quantum information cannot be destroyed. It can be transformed, scattered, scrambled beyond recognition, but never truly erased. And if consciousness is, at its root, a special organization of information, then perhaps it can endure as long as the underlying laws allow information to exist. That leads to extraordinary scenarios. The last observer could be the final configuration of the universe itself. A mind spread across the entire remaining energy field, holding within its structure the memory of everything that ever happened, like the closing chapter of a book written in the shape of reality. But would such a mind still experience time? If the universe has collapsed into a singularity, there may be no meaningful before and after, no sequence to hang thoughts on, meaning the last observer could exist in a single, eternal instant, holding its awareness without change forever. In the heat-death case, time might still exist in a technical sense, but become so diluted that it's almost meaningless, with aeons passing between moments of awareness, And in the big rip, where everything tears apart, the last observer might not be continuous at all, but rather a series of flickers, teeny bursts of consciousness in different pockets of spacetime, connected only in the memory that they are the last. Thinking about this raises another deep question. Would the last observer feel loneliness? To be conscious is to have a sense of self, and often that self is shaped by others, other people, other minds, other signals to respond to. But in the absolute end, there may be nothing left to observe except the echo of your own existence. This could be a kind of ultimate solitude, but it could also be the purest form of observation possible, with no distractions, no external forces, just the awareness of being, distilled to its essence. And perhaps that is the strange gift of being last. To see the universe without the noise of its countless moving parts, to hold its entire history in a single mind, to be the custodian of everything that was. But there's a twist. If the last observer truly holds the memory of the cosmos, then, in some sense, the universe is not gone at all. Because as long as there is awareness of it, it still exists in a meaningful way, just as a story still exists when someone remembers it, even after the book is burned. And if this is true, then the end of the universe is less an annihilation and more a transformation into a new state, where all that remains is one mind and the infinite weight of memory. For a child, you might explain it like this. Imagine everyone you know has gone home. The park is empty. The sun has set, but you are still sitting on the swing, remembering the laughter, the games, the colors of the day. Nothing is happening anymore. But as long as you remember, it feels like it's still there. The last observer would be like that. But for the entire universe, some might even wonder whether we are already in such a situation. Whether everything we see now is just the internal memory of a cosmic mind that survived the end, replaying its history from within, which would mean we are living inside the thoughts of the last observer. If so, then every star you see, every particle you measure, is both real and remembered, both happening and already gone. A strange duality that makes the boundary between past and present dissolve. And here's the most haunting possibility. Perhaps the last observer is not Summonen at all, but you, your awareness, in its most stripped down form, stretched to the scale of the cosmos, alone at the end, carrying the final truth that there was once a universe full of life, light, and wonder, and that it was seen. Vacuum residues, leftover energy fields from a finished universe. What if the universe could end, every star extinguished, every atom dissolved, every clock silenced, and yet something still remained? Not matter, not light, not even the familiar fabric of space and time, but a ghostly residue, an invisible sea of energy fields lingering after all. Structure had collapsed, the last breath of reality itself. To imagine this, you first have to understand that empty space is not truly empty, because even in the most perfect vacuum we can create, stripped of atoms, stripped of light, cooled to a fraction above absolute zero, there is still activity, a restless shimmer of energy called the quantum vacuum, born from the uncertainty principle of quantum mechanics, which says that particles and antiparticles can flicker in and out of existence in unimaginably short timescales, borrowing energy from nothing and giving it back before the universe notices. This vacuum energy is not a background detail, it's a structural property of spacetime, woven into the laws of physics themselves. And it's the reason empty space can bend, stretch, and ripple as gravity and quantum fields interact. Now, if our universe were to reach a final state, whether through heat death, big rip, or big crunch, the matter and radiation we see would disappear. But the vacuum might not vanish with them, because the quantum fields that define it do not depend on stars or galaxies to exist. They are the stage on which those things perform, and the stage remains even after the actors are gone. These vacuum residues would be the ultimate leftovers of existence, silent but still capable of influencing reality. and we already have hints of their power. The cosmological constant, which drives the accelerating expansion of the universe, can be interpreted as a form of vacuum energy. And the Casimir effect, where two metal plates in a vacuum feel a tiny attractive force, proves that this empty energy has measurable consequences. In a post-universe cosmos, where no organized matter remains, such residues could dominate completely, forming a uniform sea of energy with no ripples, except for quantum fluctuations, tiny random variations that could persist forever. And here's where it gets both eerie and profound. Those fluctuations, though small, could carry the faintest imprints of the universe's past, like the pattern of waves in a pond long after the stone has sunk, meaning that in the vacuum residue, the memory of everything might still exist in microscopic correlations between its fields. In principle, if you had unlimited precision and a perfect theory, you could read those imprints and reconstruct parts of the vanished universe, turning the vacuum into a kind of invisible archive that no catastrophe can erase. But vacuum residues also raise the possibility of rebirth. In some cosmological models, quantum fluctuations in the vacuum can tunnel into creating new regions of spacetime, tiny bubbles that expand into entirely new universes with their own laws of physics, meaning that the vacuum left after our universe ends could be the womb of future universes, each seeded from the last breath of the previous one. This ties into the concept of false vacuum decay, where our current vacuum might not be the most stable possible state. If it ever shifted to a lower energy configuration, the change would sweep across space at nearly the speed of light, rewriting the structure of reality in an instant, destroying everything we know but replacing it with something else. In that sense, the vacuum residue isn't just a passive remnant, it's an active, restless foundation, full of latent possibilities that could erupt even after the end is supposed to have happened. To explain this to a child, you could say, think of the universe like a music concert. The musicians are the stars and galaxies, and the songs are the events and changes we see. But beneath it all, there's a deep, constant hum from the sound system. A hum that doesn't stop when the band leaves the stage. The vacuum residue is that hum, still there in the silence, still shaping the room. Philosophically, this changes how we think about endings. Because if the stage remains, maybe there is no such thing as nothing. Maybe there is always a field, always an energy, always a foundation waiting to be stirred. And if consciousness, in some form, could anchor itself in that field, perhaps the end of the physical universe wouldn't mean the end of awareness. It might simply mean existing in a reality stripped down to its most minimal form, where space is just the vacuum, and time is measured only by the subtle shifts in its quantum state. The real mystery is whether these residues are truly eternal, or whether they too can fade, leaving behind an even deeper kind of nothingness that physics currently struggles to describe. And yet, even in that ultimate stillness, the rules suggest that fluctuations would inevitably return, because true nothingness may be impossible. A perfectly empty state may be unstable, always pregnant with the next something. So when you hear the phrase, the end of the universe, remember that it may not be an abrupt erasure, but a transition to a quiet, invisible ocean, the vacuum residue, carrying within it the last whispers of a cosmos that once blazed with stars, and perhaps the first whispers of whatever will come after. Phantom forces, gravity and magnetism as memory traces. Imagine walking into an empty room where every object that once stood there has been removed. The chairs, the tables, the bookshelves, all gone. And yet you still feel the arrangement of the space, as if the air remembers where things used to be in the universe. Something similar happens on a scale so vast and subtle that most of us never think about it. Forces like gravity and magnetism can persist long after their original sources are gone, lingering as invisible structures that shape the motion of matter and the behavior of energy, almost like memory traces imprinted on the fabric of reality itself. To understand why this is more than just poetic analogy, we need to look at how these forces actually work, because they're not like objects you can pick up and move. They are fields, vast invisible maps that extend through space, and when something massive or charged moves through them, it leaves behind a kind of signature. With gravity, the presence of mass curves spacetime. And that curvature doesn't just vanish instantly if the mass disappears. Instead, changes in the gravitational field ripple outward at the speed of light as gravitational waves, carrying with them the news of what happened. These waves are like the fading echo of a bell that's been struck, a record of the event that can be detected billions of years later with sensitive enough instruments. And already, detectors like LIGO and Virgo have picked up such signals from collisions between black holes and neutron stars, proving that gravity is not just a force in the moment, but a messenger carrying the memory of cosmic events across unimaginable distances. Magnetism has its own way of storing history. Magnetic fields are generated by the movement of electric charges, and they can persist for millions or even billions of years. If anchored in the right conditions, like the magnetic field of Earth, which has been recording our planet's geological history in the orientation of magnetic minerals in ancient rocks. By studying these fossil magnetizations, scientists have reconstructed the movement of continents and the reversal of Earth's magnetic poles over deep time, showing that magnetism, too, can serve as a physical archive. In fact, galaxies themselves are threaded with enormous magnetic fields, whose origins are still mysterious, but which may carry information about the early universe, perhaps seeded by tiny magnetic fluctuations, moments after the Big Bang, and then amplified over cosmic history, meaning that even the empty space between stars is not truly empty, but imprinted with the echoes of long-past events. In both cases, gravity and magnetism. The key idea is that fields are not just passive. They can store and transmit patterns, preserving information about the conditions that created them. And while these patterns can evolve and fade, they don't vanish immediately when the source changes, giving them the quality of a memory trace. Some of the most intriguing examples come from astrophysics. The gravitational lensing of light from distant galaxies can be caused by massive structures like galaxy clusters that are still there. But in some cases, the lensing pattern we see might be due to structures that have since moved or changed, meaning the light carries with it a record of the past state of the universe. Similarly, the magnetic fields observed in galaxy clusters could be frozen in relics from an earlier cosmic epoch, surviving even as the matter around them has rearranged, much like a photograph capturing a moment that no longer exists. On a quantum level, the situation becomes even stranger. Fields can have vacuum states that retain imprints of past interactions. And in certain theories, gravity itself might encode a kind of holographic record of everything that has ever crossed a given boundary in spacetime, just as black hole event horizons are thought to store information about what has fallen in. This idea that forces are not just influences but record keepers forces us to rethink the boundary between now and then, because it means that traces of the past are woven into the forces shaping the present, and in principle, if we could measure them with infinite precision, we could reconstruct history from them. To explain it to a child, you might say, imagine dragging your finger through a sandbox. The groove you leave stays there even after your hand is gone, and the wind may change its shape slowly. But for a while, the sand remembers exactly where you moved. Gravity and magnetism are like the grooves in the cosmic sandbox, except they are etched into space itself, and the wind that erases them can take millions or billions of years to blow. This also raises profound questions about the ultimate fate of information in the universe. If the sources of these fields are destroyed, stars collapsing into black holes, planets torn apart, do the fields they created keep any part of their story? Or does the information eventually dissolve into random noise? Current physics suggests that while the fine details may fade, the overall patterns can persist for astonishing lengths of time, making these phantom forces some of the most durable witnesses to the history of the cosmos. And here's the haunting thought. Right now, the gravity pulling on your body and the magnetic field guiding your compass are not just abstract forces. They are the living echoes of ancient motions, The pull of Earth's gravity is shaped by the way our planet formed billion years ago, and its magnetic field still carries the imprint of molten iron currents deep within, currents that have been flowing since before the first life appeared. In this way, every step you take, every direction you face, is influenced by the long memory of forces that were set in motion long before you were born. So the next time you drop something and watch it fall, or see a compass needle twitch toward north, remember that you are interacting with a story that began eons ago, a phantom trace of the universe's past, still shaping your present in ways both subtle and profound. Particle afterlife. How matter could exist after time ends. Picture the end of everything you know. Not just the fading of stars or the collapse of galaxies, but the moment when time itself no longer has meaning, when the ticking of clocks, the rise and fall of events, and the very sequence of before and after dissolve into nothing, leaving behind a reality with no forward or backward, no change at all. And yet, in this stillness, matter could remain, persisting in a strange particle afterlife, where existence continues without the flow of time. To even begin to imagine how this is possible, we have to separate two concepts we usually treat as inseparable: matter and time, because in everyday life they are bound together. You see objects move, decay, or transform only as time passes. But physics teaches us that matter, at its most fundamental level, is built from quantum fields, whose existence doesn't necessarily require time to flow in the way we perceive it. In fact, when scientists write down the equations that describe particles like electrons, quarks, or photons, those equations don't inherently care about a preferred direction of time. They can be run forward or backward, and the mathematics still works. It's our experience of entropy, the gradual spreading of energy and increase of disorder, that gives us the arrow of time. But if the universe reached a point where entropy could no longer increase, like in the so-called heat death scenario, then time, as we know it, might lose its direction entirely, freezing the large-scale evolution of the cosmos, while leaving the underlying quantum fields still existing in a kind of static equilibrium. In this frozen stage, particles could persist indefinitely, not aging, not decaying, unless they belong to the rare types that are intrinsically unstable, like certain radioactive nuclei or free neutrons, which would have long since vanished in the earlier epochs of cosmic history, meaning that the matter left behind in this timeless realm would be composed of the most stable building blocks nature has to offer: protons, electrons, and perhaps neutrinos, along with any exotic, stable particles we haven't yet discovered. But here's where things get fascinating. If protons eventually decay, as some grand unified theories predict, then even those would be gone after about 10 to the power of 34 years, leaving only lighter particles like electrons and positrons, photons and neutrinos, all of them in a near-perfect balance where nothing has enough energy to change into anything else. Yet they would still exist, floating in an eternal stillness. And if time had truly ended in the thermodynamic sense, they wouldn't even experience that eternity, because without change there is no duration, no sequence. These particles would simply be without any sense of how long they have been. This is the heart of the particle afterlife. The idea that existence doesn't require the passage of time, only the stability of the fields and laws that define it. And there's another layer to this. Quantum mechanics suggests that particles are excitations of fields that permeate all of space. And those fields don't vanish just because time's arrow stops. As long as the fields themselves persist, their lowest energy configurations can still support the existence of particles, even in a universe where no macroscopic events occur. In this sense, the particle afterlife isn't just a hypothetical. It's an almost inevitable consequence of the fact that energy and matter can exist in equilibrium without change now. From a philosophical point of view, this raises haunting questions. If the universe in its final state still contains matter, but nothing ever happens, can we say that universe is alive in any sense? Does existence require events, or is the mere presence of particles enough? Imagine a museum where every exhibit is locked in glass cases forever, with no visitors, no curators, no rearrangements. Nothing changes, but the exhibits are still there. Intact, the particle afterlife is like that museum, except the exhibits are protons, electrons, and photons, and the museum is all of space. And even stranger is the possibility that the particle afterlife could itself become the seed for something new. Some cosmological models suggest that quantum fluctuations can happen even in this frozen state. Tiny random blips that could, given unimaginable spans, accumulate into larger structures or trigger a new phase of expansion, creating a fresh arrow of time. In that case, the afterlife of particles might not be eternal stillness, but a long, silent interlude before a new cosmic act begins. For a child, you might explain it this way. Think of a playground after everyone has gone home at night. The swings hang still, the slide is empty, nothing moves, but the playground is still there, waiting unchanged in the particle afterlife. The playground is the universe itself, and the swings and slides are the particles, sitting quietly without anything to do. Scientifically, this concept also forces us to reconsider the meaning of end in physics. If the material components of the universe survive beyond the death of time, then ending might be more about transformation than annihilation, with the drama of cosmic evolution giving way to a static tableau, a final sculpture of matter arranged in whatever form the last interactions left it. And here's the twist. Because relativity teaches us that time can flow at different rates for different observers depending on their state of motion and gravity, the end of time could be a local phenomenon in some interpretations. There might be regions where time has effectively stopped, while others still experience change, meaning that pockets of the particle afterlife could already exist in extreme environments, like the event horizons of black holes, waiting for the rest of the universe to catch up. If so, the afterlife isn't just a far future possibility. It's a feature of the universe right now, hidden in places we can't see. So the next time you think of the universe ending, remember, the story might not close with an empty nothingness, but with a quiet persistence, a lingering presence of matter stripped of time's touch, an eternal museum of particles holding their places in the dark, waiting for a clock that will never start again. The cosmic dream hypothesis. Everything is the final thought of the universe. What if everything you have ever known, every star in the sky, every mountain and ocean, every person you have loved, every thought you have had, was not part of a physical universe moving forward in time, but the last dream of a cosmos that has already ended, the final flicker of consciousness before it falls into eternal silence? The cosmic dream hypothesis begins with a strange and beautiful idea that consciousness is not merely a byproduct of the universe, but something woven into its fabric. And if the universe could give rise to awareness during its long unfolding, perhaps it could also experience a final moment of awareness as it ends, a single infinite thought that contains the memory of all that came before. To understand why this is even conceivable, you have to step back from the everyday picture of reality as a set of objects and events, out there moving independently of any observer. Because modern physics has already shown us that observation and reality are deeply entangled. The quantum world does not offer a definite state until it is measured. And, in a profound sense, the act of knowing is part of what makes the known real. If this is true in the microcosm, could it also be true on the larger scale? Could the entire sweep of cosmic history, from the Big Bang to the death of the last star, be a kind of vast mental narrative that the universe is telling itself? In our own minds, dreams can compress lifetimes into minutes, or stretch moments into what feels like hours, and they have their own internal logic, their own physics. In the cosmic dream hypothesis, the final thought of the universe could work the same way. It might not unfold according to the ticking of a clock, but according to the structure of the thought itself, holding within it the totality of space, time, and memory, as an internally consistent whole. This idea gains an eerie plausibility when you realize that the speed of conscious experience is not fixed. Our brains create time for us by sequencing events. But those events are just patterns of electrical activity, and there's no law that says they must be tied to the same cons that an external clock measures. If a universe-sized mind existed in the final instant of reality, it could, in theory, simulate the entire life of the cosmos within itself, experiencing billions of years of history in what, from the outside, would be no time at all. The key question then becomes, how could such a mind exist, and what would it be made of? In one scenario, the mind is simply the sum total of all conscious beings in the universe, as they approach the end, connected through some deep physical substrate, perhaps through the quantum fields that underlie space itself, merging into a single unified awareness as the conditions for individual existence fade. In another, more speculative scenario, the universe itself is the mind. Its matter and energy have long since transformed into patterns of pure information, and as the physical structures break down in the final collapse or fade, those patterns converge into one last coherent state. Like the brain activity of a sleeper entering their final dream, this is not without precedent in physics. When systems approach certain extreme limits, their complexity can sometimes reduce to a single dominant mode, a kind of ground state that captures the essence of everything before. And if the universe is, at bottom, an information processing system, then the cosmic dream could be that ground state holding the compressed symbolic memory of the entire cosmos in one final moment of self-reflection. Philosophically, this reframes what an end really is. If the universe dies with such a thought, then in a sense, it does not end at all, because that thought is not bound by time. It simply is, unchanging, eternal from its own point of view, even if from ours it appears to be the briefest flicker. To a child, you might explain it like this. Imagine the day is over. You are falling asleep, and in your last dream of the night, you relive every moment of the day at once. Not in order, but all woven together in a single feeling that contains everything. When you wake up, the day is gone, but that last dream is still complete inside you. In the cosmic version, there is no waking up, but the dream itself is the final reality. And here's the part that might make you shiver. If we are living in that dream, then everything we experience is both real and remembered, both happening and already over. And the flow of time we feel is just the structure of the dream, not an external fact. In this way, the cosmic dream hypothesis ties into other deep mysteries, like why the laws of physics are so perfectly tuned for life, or why consciousness exists at all. Because if the universe's final act is to dream itself, then perhaps all of cosmic history was, in a sense, a path toward the conditions that would make such a dream possible. Maybe the vastness of galaxies and the birth of stars were just the scaffolding needed to create complex beings, who could eventually merge into the final dreamer. Maybe the physics we observe now is simply the log of the dream we are inside, and the most unsettling implication is that the dream could be recursive. If the dream contains the memory of the entire universe, then within it is the memory of the universe's end, which is the dream itself, looping forever in a perfect circle of self-awareness in such a loop. There is no clear start or finish, just the dream thinking of itself eternally. Whether this is beautiful or terrifying depends on how you feel about the idea that reality might be entirely mental at its deepest level, that matter and energy are just the contents of a thought too large for any one mind to hold, and that you, right now, are a neuron firing in the brain of a universe, having its final infinite moment of consciousness. Light cones as memory paths. How space-time stores the past. If you could peel back the invisible fabric of reality and look at the architecture beneath, you would find that the universe has already built a perfect archive of its entire history, not in books or data drives, but in the very structure of space-time itself. And the key to finding that archive lies in something called a light cone, a concept that sounds abstract until you realize it is the ultimate map of what is possible to know, to influence, and to remember. To understand it, Imagine a single event, say, a match striking in the dark, and picture the light from that tiny flame spreading outward in every direction, forming an ever-expanding sphere. If you could trace that sphere through time, it would sweep out a cone-shaped region in space-time, with the point of the cone at the moment the match struck, and the widening opening representing all the places the light could reach as time moves forward. That's called a future light cone. And it contains everything that could, in principle, be influenced by that one moment. Now turn the idea upside down. If you stand in a particular place and time, your past light cone is the set of all events that could have possibly affected you, everything whose light or any other signal has had time to reach you. These cones are not just diagrams in a textbook. They are the physical record of causality itself, marking the boundary between what is real for you and what is forever beyond your reach. Here's where the memory part comes in. The shape and content of your past light cone contains the full set of events that define your personal history in the universe. And the same is true for every point in space-time, meaning that space-time as a whole is a vast four-dimensional weave of overlapping light cones, each preserving the sequence of causes and effects that led to that location. In this sense, the past is not gone in the way we usually think. It is embedded in the geometry of space-time, and if you could somehow move along the right path or measure the right signals, you could, in principle, retrieve it. In fact, every particle of light you see from distant stars right now is a messenger from its own past light cone, carrying with it the state of the universe as it was when that light was emitted. And because the speed of light is finite, looking outward in space is always looking backward in time. Telescopes are not just instruments, they are time machines. And the more powerful they are, the deeper into the past light cones they can peer. But light cones also define the limits of knowledge, because there are regions of the universe outside your past light cone whose light will never reach you, no matter how long you wait. These events are elsewhere in space-time, causally disconnected from you forever, and they represent the parts of reality that are not just unknown but unknowable. Now imagine the entire universe as a tapestry of these cones, each one a frozen record of what could be known from that point, overlapping and intersecting in ways that create a kind of cosmic memory network. This isn't just philosophy, it's baked into Einstein's theory of relativity, which says that space-time is not a static stage, but an active player in the drama of cause and effect, and light cones are its rules for what counts as before and after, possible and impossible. The profound thing is that these cones are not arbitrary. They are shaped by the actual events of the universe. So when something dramatic happens, like a supernova or a collision of black holes, its future light cone becomes a permanent feature of spacetime's memory, carrying that event's influence outward forever. Gravitational waves, like light, travel at the speed of causality, meaning they also define their own cones. So the memory of an event is not just in the photons it emitted, but in the ripples it sent through spacetime itself. Scientists have even detected something called the gravitational wave memory effect, where spacetime is permanently shifted after a passing wave, leaving a subtle but lasting imprint of the event. Proof that spacetime does not just relay messages, it keeps them from a philosophical standpoint. This means the past is not erased. It's simply located somewhere else in spacetime, and the light cones are the addresses where it lives. To a child, you might explain it like this. Imagine the world is made of millions of soap bubbles that are always touching and overlapping. And each bubble is the space and time you can know about from where you are. And when something happens inside one bubble, its ripples spread out into the others, but never faster than the ripples can travel. Your life is just the path your bubble takes through the foam, collecting all the ripples it can. And here's the strange twist. Because the geometry of spacetime can bend and stretch under gravity, light cones themselves can tilt, warp, and change shape, meaning the memory paths of the universe are flexible, and events that were once invisible to you can, in principle, be brought into your reach, if spacetime is curved in the right way. This is how gravitational lensing works. Light from a distant galaxy might be bent around a massive cluster, so that it enters your past light cone, even though it was originally headed elsewhere, effectively letting you remember something your unaltered path could never have seen. In extreme cases, near black holes or in the warped spacetime of the early universe, light cones can be so distorted that they fold back on themselves, creating situations where events could influence each other in loops, blurring the line between memory and prediction. All of this suggests that spacetime is not just a stage, but an active memory keeping system, and the light cone is its filing cabinet. One for every event, forever. The haunting question is whether these records are truly eternal in a universe that expands forever. Light cones stretch too, and the signals from the past become ever fainter, redshifted until their energy is nearly zero, but in principle, they still exist, just harder to read. In a closed universe that collapses, light cones could converge, bringing the entire past into contact with the final moment. Like all the memories of a lifetime flashing before the mind of a dying being, and in the most speculative ideas, if space-time itself can be preserved or reconstructed, whether by an unimaginably advanced civilization or by the laws of physics in some deeper reality, then the entire history of the universe could be replayed from these embedded memory paths, as if opening a library that was always there but never fully read. So the next time you look up at the night sky, remember that every star's light cone is reaching out to touch yours. Every photon you see is a page from a chapter already written, and that somewhere, far away in the geometry of the cosmos, the full record of the universe's past still lies encoded in the angles and intersections of light. Relic neutrinos, subatomic proof of a universe that's already gone, long before the first stars lit up the darkness, before galaxies spiraled into being, before there was even light that could travel freely through space. There were particles already in motion, ghostly, almost impossible to detect, yet so numerous that even now billions of them are passing through your body every second without leaving a trace. And these particles, called relic neutrinos, are not just relics in name. They are literal survivors from the first heartbeat of the cosmos, the last unbroken physical link to a universe that no longer exists. And if we could capture them in detail, they would offer proof, etched at the smallest scales, that we are living in the aftermath of something long finished. To grasp how extraordinary this is, you need to picture the universe, not as we see it today, vast and cool, but as it was in its first second of existence, a seething plasma of particles and energy so hot and dense that nothing could travel far without colliding with something else. A reality in which neutrinos, tiny, neutral particles with barely any mass, were being created in huge numbers in the chaos of particle interactions. In that first second, the temperature was about 10 trillion degrees, and the density was such that even light was trapped, scattering endlessly off charged particles. But neutrinos, because they interact only through the weak nuclear force and gravity, could slip away more easily, though even they were constantly colliding at that early stage. Then came a moment physicists call neutrino decoupling, about 1 second after the Big Bang, when the universe had expanded and cooled enough that neutrinos no longer interacted significantly with other matter, freeing them to stream across the cosmos unimpeded, carrying with them the exact imprint of the conditions in that moment. These are the relic neutrinos, and they have been traveling ever since, untouched, unchanged, except for the stretching of space itself, which has redshifted them from blisteringly energetic particles into unimaginably cold ones today, with an average temperature of just 1.95 kelvins, barely above absolute zero. They form what's called the cosmic neutrino background, a faint ocean of subatomic messengers that fills all of space, far more numerous than the photons of the better-known cosmic microwave background, yet so elusive that we have never directly detected them, because their interactions with matter are so weak that they pass through planets, stars, and even entire galaxies, as if they were not there. But their existence is not just a theoretical curiosity. It's a direct prediction of the standard model of cosmology. and the patterns we see in the cosmic microwave background and in the distribution of galaxies are consistent only if this ancient sea of neutrinos is real. If we could detect them, we would be looking at the oldest physical evidence in the universe, older even than the first light. Because these neutrinos escaped the early plasma before photons could, making them a kind of pre-light fossil record, an archive from a time we can otherwise only model with equations. Detecting them would be like finding an untouched time capsule from before there were stars, before there were atoms, before the universe had any structure at all, and reading inside it the precise conditions of the newborn cosmos. But here's where the idea becomes even more profound. Relic neutrinos are not just proof of the universe's beginning, they are also proof that the universe we live in is already in a sense over, because they belong to an era that has ended completely, an era whose physics no longer exists in the same form. The hot, dense conditions of the early universe will never return naturally. So these particles are like the embers of a fire that has gone cold, drifting through a vastly changed environment, yet still carrying the properties of their origin. They are the ultimate cosmological ghosts, ever present, yet entirely disconnected from the energetic, structured universe of today. And if the cosmos were to end in heat death, trillions of years from now, when all stars have died, and all matter has decayed, these neutrinos would still be there, thinner and colder than ever, but still carrying the memory of that first second, outlasting everything else we know. Their detection would require technology beyond anything we currently have, experiments so sensitive they could spot the faintest whispers of interaction when a relic neutrino occasionally nudges an atomic nucleus. A feat we've only begun to approach, with detectors like precision tracking of low-energy electron measurements, which hopes to use tritium's rare interactions with neutrinos to finally see these ancient travelers. If successful, it would be the first time we've touched matter from the first second of time, the oldest artifact in existence. To explain it to a child, you might say, imagine the universe was once a big crowded playground where everyone was running and shouting, and then the game ended, and everyone left, except for a few kids who had slipped out early, still running quietly across the field, even after it was empty. Those kids are like relic neutrinos, still moving through space after the universe's busy beginning ended. Scientifically, studying them would let us test our deepest theories about how matter formed, how the forces of nature behaved at the highest energies, and even how many kinds of neutrinos exist, including possible exotic types we have never seen. Philosophically, they remind us that the past is never truly gone. It is woven into the present in forms so subtle that we usually miss them, yet they shape everything around us. And here's the haunting thought right now. Without knowing it, you are being passed through by particles that have been traveling since the first heartbeat of the universe. Particles that were already ancient before there were stars, before there were planets, before there was an Earth for you to stand on. And they will still be passing through whatever reality exists long after our world, our sun, and even our galaxy are gone. The relic neutrinos are the quietest possible proof that the universe we see is just one frame in a much larger story, and that somewhere, buried in the cold and silence of the present, are the eternal messengers of a cosmos that has already moved on. The holographic memory model, space as a perfect record. Imagine for a moment that everything around you, the walls, the sky, your body, even the deepest folds of your mind, is not so much a place as it is a page in a perfectly arranged record, as if the universe itself were an immaculate archive, and you are not simply living inside it, but are a moving needle tracing over its grooves, moment by moment reading what has already been inscribed into the very structure of reality. This is the strange and fascinating proposition behind the holographic memory model. The idea that space itself might act like a flawless storage medium, retaining every detail of every event that has ever occurred. It's a concept that forces you to rethink what pasts and present even mean. Because in such a framework, nothing is ever truly gone. The information about it is still here, hidden in the fabric of the universe, waiting to be accessed. The holographic analogy isn't chosen for poetic effect alone. It's grounded in real physics and neuroscience. In a hologram, every fragment of the plate contains information about the whole image. Meaning, if you break it in half, each half still carries the entire picture, just with less clarity. Similarly, in the holographic memory model, every point in space could carry the full informational pattern of the universe, interwoven and encoded in ways that resist our ordinary sense of location. This idea connects deeply with the work of physicist David Bohm and neurophysiologist Carl Pribram, who, working in different fields, arrived at eerily parallel conclusions. Bohm suggested that the universe itself might be a kind of hologram, what he called the implicate order, where all points contain all others, while Pribram found that the brain's storage of memory might operate not like a filing cabinet, but like a holographic interference pattern, with memories distributed across the entire neural network, rather than stored in isolated locations. If this is true, your brain doesn't just hold fragments of past experiences in neat compartments. Instead, the patterns of light, sound, smell, and emotion from your life may be encoded in a way that allows them to be reconstructed from any part of the system, much like a hologram can be recreated from any fragment of the original plate. But when this concept is extended beyond the brain into the cosmos, it becomes far more unsettling. It suggests that space itself is a living memory field, a kind of cosmic mind in which the positions and states of all particles are not just fleeting configurations, but enduring imprints etched into the underlying quantum fields. This connects to what physicists call the holographic principle, an idea born from studying black holes, where the information about everything that falls into them seems to be preserved on their event horizons, as if the entire three-dimensional contents are written on a two-dimensional surface. Some have proposed that the same principle applies to the entire universe, that our 3D reality is like a projection from data stored on a cosmic boundary, and that where and when are less important than how the information is woven together. If this were the case, then the past is never destroyed, only transformed into a pattern so intricate and diffuse that it becomes inaccessible to ordinary perception. You could imagine space itself as a perfect historian, never omitting a detail, no matter how small: the flutter of a moth's wings in ancient forests, the silent fall of dust in a forgotten room, the exact configuration of atoms in a raindrop that fell millions of years ago. All still here, embedded in the structure of space-time. The real mystery is not whether the record exists, but whether it can be read. Could there be a way, through some unimaginable technology or a future leap in consciousness, to tune into these patterns, to replay events not as imperfect reconstructions in memory, but as direct experiences from the original imprint? If so, history would no longer be a matter of interpretation. It would be a direct encounter with the real thing, an unaltered replay of what truly happened. The implications are staggering. Justice could be absolute, because every crime and every kindness could be seen exactly as they were. Ancient mysteries. The building of the pyramids, the extinction of the dinosaurs, the birth of the first star could be observed with perfect accuracy, and on a more intimate level, you could revisit moments of your own life not as faded recollections, but with all the sensory richness and emotional depth of the original. But here lies a paradox. If everything is recorded perfectly, what does it mean to forget? In the brain, forgetting might simply be losing access to certain interference patterns. In the universe, perhaps the same principle applies. The information is still there, but you lack the key to unlock it. This raises haunting philosophical questions. If space remembers everything, does it also remember you? Will the record of your life, every breath, every word, every heartbeat, continue to exist long after your body is gone, preserved in the silent architecture of the cosmos? And if so, does that make you, in some sense, immortal? Or does it mean that your existence is simply part of a vast, indifferent archive? One tiny thread in an infinite tapestry, never singled out but always there, waiting to be found by anyone who knows how to look. You might already be living inside the ultimate library, one where no page is ever torn out, no ink ever fades, and the story never truly ends. The only question is whether you'll ever learn how to read the book you're in. Redshift as decay. Are we seeing the universe's funeral colors? What if the faint red glow of distant galaxies, the very light astronomers use to measure the size and age of the cosmos, isn't just a sign of movement, but the slow fading of the universe itself, like the embers of a fire that has already burned most of its fuel? You've probably heard that redshift means galaxies are racing away from us, stretching their light into longer, redder wavelengths as space expands, much like the lowering pitch of a siren moving away. But there's another, far more haunting interpretation, one that doesn't see this reddening as a simple Doppler effect, or the stretching of wavelengths in expanding space, but as a kind of cosmic decay, a gradual loss of energy that might be telling us we are looking at the funeral colors of a dying universe. In this view, redshift isn't just a measurement of velocity, it's a symptom, a sign that photons themselves are growing old, their vitality bleeding away as they travel through the deep and ancient dark. This idea, though far from the mainstream, taps into a question that cosmology has never fully answered. What really happens to light over billions of years? In the standard model, a photon's energy is reduced because space itself is stretching. But in a decay model, the photon loses energy intrinsically, almost like radioactive elements that fade into more stable forms. This is often called tired light, an old hypothesis discarded by most astrophysicists because it couldn't explain certain observations, like the time dilation seen in supernova light curves, or the uniformity of the cosmic microwave background. Yet, there are versions of this idea that go deeper, suggesting that decay may not be a mechanical loss, but a transformation, an entropic fading that is written into the nature of the universe itself. Think about it. The color red is the lowest energy visible light we can see, the final rung before light slips into the invisible infrared and beyond. When we look at galaxies so far away that their light left them billions of years ago, we are already seeing them diminished, not in brightness alone, but in frequency. Their light cooled, their vitality drained. If redshift is decay, then every step down the spectrum is a step toward silence, and the deep red glow of the farthest objects we can detect might be the faint whisper of things that are already gone. Imagine walking into a vast ancient cathedral after a great choir has sung its last note. The walls still carry the faint resonance, but the music itself is no longer being made. What you hear is the echo fading with every second. In the same way, if photons decay, then the light from distant stars is an echo in frequency. Each vibration slower, each oscillation lazier than when it began, not because space is pulling it apart, but because time itself is wearing it down. The implications of this are staggering, because it would mean the universe has a built-in color clock, and every photon we catch is a timestamp of its own demise. In an expanding universe model, redshift gives us distance. In a decay model, it could give us age, not just in terms of travel time, but in terms of how far along that photon is in its journey toward oblivion. This reframes the cosmos as something more fragile, more mortal, not an endless arena in which light simply stretches, but a place where light itself can die, where information fades not because it is too far away to reach us, but because it's eroded into nothingness on the way. The more you think about it, the more this possibility gnaws at you. Are we looking at the galaxies themselves, or only at their funerary shrouds, their last dim embers? In the decay interpretation, the cosmic microwave background, the faint afterglow of the Big Bang, would not just be a remnant of an early hot phase, but the residue of light that has decayed into near thermal equilibrium, the cold ashes of a once blazing fire. Every degree of that background's temperature, every faint photon within it, could be the end point of a journey that began with unimaginable brilliance. If this is true, then the visible universe is like a museum lit by dying bulbs, and the farther you look, the deeper you are staring into the shadows left behind by the fading glow. It also forces us to confront a disturbing question about the future. If photons decay, then even if stars continue to shine forever, their light would never remain as we see it now. Across billions and trillions of years, all light would slide into longer and longer wavelengths, until the cosmos is nothing but a bath of radio waves, so stretched and weak, they can no longer do work, no longer form images, no longer tell a story. The universe wouldn't end in a sudden catastrophe, but in a slow, colorless erasure, the ultimate loss of contrast, the draining of the cosmic palette. And yet, in such a model, there might also be a strange kind of beauty, because decay isn't simply destruction, it's also transformation. Just as autumn leaves turn red before they fall, the reddening of the universe could be a phase of profound change, a sign that the cosmos is cycling into a new state we cannot yet imagine. Perhaps those long, stretched photons become part of a deeper informational fabric, their lost energy feeding into processes we have no name for. In that sense, the funeral colors might not mark the end of the story, but the turning of a page in a book too vast for us to read in full. Of course, mainstream cosmology continues to interpret redshift as a clean, geometric effect of expansion, supported by the success of the Big Bang model in predicting cosmic background radiation and the abundance of light elements. But even in this view, the poetry of decay lingers, because expansion itself, over time, will push all light toward longer wavelengths until galaxies beyond our local group slip entirely beyond detectability, their redshift effectively infinite. Whether through decay or expansion, the universe is redshifting toward darkness. And the color we see now, the rich reds of ancient galaxies, the faint blush of light stretched to its limit, is a preview of that darkness. And so, when you look through a telescope and see a galaxy's light smeared toward crimson, you might not just be looking across space, but across the arc of mortality, watching not only a place far away, but a moment in its dying, the exact hue of a note as it fades from hearing. Maybe in the end, redshift is both motion and decay, both the Doppler stretch of expansion and the slow bleeding of energy into the fabric of space. And maybe that's the true funeral color, not pure red, but the knowledge that even light, the fastest, purest thing we know, cannot outrun the universe's long, patient erasure. In that sense, we are not just observers of the cosmos, we are witnesses at its wake, listening as the choir of galaxies sings its last long note into the dark, knowing that someday even the red will fade. The dead universe illusion. Why expansion could be a memory artifact. What if the universe we think is expanding all around us is not expanding at all, but instead, the redshift and fading we observe are nothing more than the fingerprints of a colossal memory, an ancient recording still playing, long after the events it depicts have ended. Imagine standing in a silent theater after the final act of a grand performance. The actor's gone, the stage empty, but the sound system still broadcasting an echo of their voices from a distant time. To you, it feels live. But in truth, you are only hearing the preserved imprint of something long over. The dead universe illusion takes this unsettling analogy and applies it to cosmology. Perhaps all the light we see, every spectrum from the nearest star to the faintest galaxy on the edge of visibility, is the leftover radiation of a universe that has already gone cold and lifeless. And the reason we believe we live in a dynamic, expanding cosmos is because we are embedded in the lingering afterimage of its past. In standard cosmology, the light from distant galaxies is redshifted because the space between us is stretching, lengthening the wavelength of each photon as the universe expands. With this expansion supported by the cosmic microwave background and the apparent acceleration inferred from type Ia supernovae. But what if those redshifts are not a Doppler, like stretching caused by space's growth, but a spectral aging effect, a property of light interacting with a decaying substrate of reality, where the structure of space-time itself has frozen, but continues to transmit the record of its last living moments? In this interpretation, the entire observable universe becomes like the grooves of a phonograph record, etched with the vibrations of events that no longer occur. Your eyes are the needle, scanning those grooves in sequence, translating patterns of frequency and intensity into the illusion of unfolding history. That would mean time as we experience. It is not a river flowing forward, but a needle tracing backward across a spiral, with the present nothing more than the point where perception meets the stored imprint. This memory artifact hypothesis aligns in strange ways with certain quantum interpretations, particularly those that treat the universe as fundamentally informational, where what exists is not matter or energy in motion, but data structures whose readout gives rise to the illusion of motion. If the expansion we measure is simply the gradual degradation of stored light signals, then the accelerating part of that expansion could be a byproduct of how memory fades. The farther away a galaxy is, the more that information has degraded, shifting into longer wavelengths. Not because the galaxy has sped away, but because the medium of storage has undergone entropy, just as old photographs fade, or old recordings distort with static. In that case, the accelerating universe is less a firework still bursting, and more an ancient mural with its paint peeling at increasing rates the further from the center you look. This turns many of our assumptions on their head. The cosmic microwave background would no longer be the literal thermal remnant of a Big Bang, but the lowest energy residue of the universe's final signal, the last broadcast of its heat before the lights went out. Galaxies themselves, as we see them, might no longer exist, not because they are too far to reach, but because they are part of a historical dataset that stopped updating billions of years ago. That means that in real time, beyond the boundary of the recorded data, there could be nothing left but a static, unchanging void, while everything we take for reality is an immersive playback we can't distinguish from a live feed. Such a concept would also reframe our notion of cosmic distances. In the standard model, looking deeper into space means looking further back in time. In the memory illusion model, looking deeper means accessing earlier parts of the archive, with each increment of distance pulling us closer to the last moment before the freeze. Even the Hubble constant, the rate of expansion, could be nothing more than the decay rate of recorded wavelengths, and its slight variations across different measurements might be telling us about the irregularities in how the universe's final state was stored. This idea even raises questions about our own place in the archive. If we too are patterns in this stored data, then our thoughts, choices, and lives are not unfolding in an active present, but are the automatic replay of states already fixed. The inevitable reading of grooves already carved. It's an existentially dizzying possibility that free will, change, and the flow of time are perceptual artifacts within a closed loop of recorded information. And yet, it offers a strangely poetic resolution to some puzzles in cosmology. Why the large-scale structure of the universe looks so static, why the cosmic microwave background is so uniform, why there is a horizon beyond which nothing can be observed. Because beyond that horizon lies not new space, but the edge of the stored image in this sense. Our telescopes are not windows, but projectors, turning the ancient cosmic negatives into the living light of our skies. If this is true, then the fate of the universe has already been sealed, not in some future heat-death trillions of years from now, but in a past so far behind us that what we call now is merely the ghost of what was. The tragedy is that we can never step out of the playback to confirm it. The miracle is that the illusion is so perfect, it feels real in every heartbeat and photon. So the next time you look at the deep red glow of a distant galaxy, ask yourself, are you witnessing its current state across space? Or are you touching the cooled embers of a world long vanished, glowing only because the archive is still spinning? If the dead universe illusion is true, then we are not living in an expanding cosmos at all. We are living in the afterglow of its final sunset, walking inside a masterpiece of memory, unaware that the painter laid down the last stroke eons ago. Observer persistence. Why awareness might outlive physical reality. What if awareness, the raw fact of experiencing, is not bound to the lifespan of the body or the persistence of the physical universe, but continues, in some form, after the stage on which it once played, its part has already collapsed into nothing? Not in the sense of a ghost floating through the afterlife as culture often imagines, but as a deeper principle, that consciousness might be a fundamental property of reality, and thus not subject to the same decay, dissolution, and erasure that matter and energy inevitably face. In physics, everything we know, particles, fields, forces, can be described by interactions that unfold within space and time, and all of them obey the arrow of entropy. Structures break down, heat disperses, complexity eventually fades. But awareness itself is not a thing, in the usual sense. You cannot measure it in kilograms or meters. You cannot locate it in the way you locate an electron or a photon. Neuroscience can map the patterns of brain activity that correlate with conscious states. But correlation is not identity, and the question of whether awareness is generated by matter or merely hosted by it remains unanswered. If awareness is not produced by matter, but instead is a feature of reality at the same ontological level as space, time, and energy, as some interpretations of quantum mechanics, panpsychism, and idealist philosophy suggest, think of a radio broadcast. Smash the radio, and the music stops for you. But the broadcast still exists, moving through space, unchanged by the destruction of your receiver. In such a framework, your brain is the receiver, and death is the smashing of the hardware. But the signal, the fundamental capacity to be aware, may persist, not as your personality or memories, but as a bare field of sentience in which new patterns could form. Now imagine applying this idea, not just to individuals, but to the entire cosmos. The laws of thermodynamics predict that the universe will one day reach maximum entropy, a het death in which all usable energy is gone, all gradients flattened, all structures erased. In the standard picture, this would be the end of everything. No stars, no planets, no chemistry, no life, no thought. But if awareness is not a byproduct of complexity, but a foundation of existence itself, then the end of the universe's physical complexity might not extinguish it. Instead, awareness could remain as a kind of undifferentiated, contentless presence, existing without space or time in the way we know them. This aligns in strange ways with certain interpretations of quantum mechanics, especially those that treat observation, the collapse of the wave function, as a fundamental act that brings reality into a definite state. If observation is what crystallizes the world from quantum probability, then it is not a product of the world, but a shaper of it. Remove the stage, and the shaper still exists, perhaps waiting for a new stage to arise. Some thinkers have speculated that this observer persistence might even be the engine of cosmic renewal, that awareness unable to be destroyed could seed a new universe by shaping quantum fluctuations into structure, much like it allegedly does at the microscale in experiments. In that case, what we call the Big Bang might not have been the absolute beginning, but the moment an eternal awareness gave rise to a new physical order after the last one decayed. It is an unsettling inversion. Instead of consciousness being a temporary spark, lit by matter, matter would be the temporary form through which consciousness chooses to express itself. But even without cosmic cycles, the persistence of awareness would change the way we think about death and existence. It would mean that what you are at the most basic level, the raw knowing that anything is happening, cannot be erased. Even if every detail of your life, every memory and sensation dissolves. Some argue that this could explain certain phenomena that otherwise seem anomalous. Near-death experiences, moments of awareness reported when brain activity is supposedly absent, or the peculiar sense in deep meditation of a pure witness beyond thoughts and sensations. These are often dismissed as quirks of brain chemistry. But if awareness can exist without the structures we associate with it, they might be glimpses of its independence. On a more philosophical level, this possibility forces you to confront what you actually are. If your identity is built on memories, roles, preferences, and relationships, and all of that is contingent on the physical brain, then persistence of awareness, without those elements, would be the persistence of something you cannot recognize as you, the survival of the mirror without the image it once reflected. That can be terrifying or liberating, depending on your perspective. Terrifying, because it suggests that the you who fears death will not be the one who experiences whatever comes after. Liberating, because it suggests that the core capacity to experience is untouchable. In this light, the physical universe becomes a temporary artwork in the gallery of awareness, displayed for a time and then taken down. But the gallery itself remains, ready to host another. Mainstream science, of course, does not assume awareness exists independently of matter. Most neuroscientists hold that consciousness emerges from complex computation in the brain, and without that substrate, there is nothing. But the persistence hypothesis isn't easily dismissed, because consciousness remains the one phenomenon for which there is no agreed upon physical explanation, the hard problem of how subjective experience arises from objective processes. And until that is solved, the door remains open to the possibility that awareness is not emergent but fundamental. If it is, then its persistence beyond physical reality would not be supernatural but natural in the deepest sense, simply the continuation of what cannot be reduced to anything else. From this perspective, the end of the universe is not the end of being, but the end of a chapter, and the beginning of a strange, formless interval in which awareness exists without objects to be aware of, until something, perhaps inevitably, gives it a new stage. This vision is not meant to comfort or to threaten, but to provoke the question: if the observer outlives the observed, what then is the meaning of the world we currently inhabit? Are we here to learn, to shape, to remember, to prepare for the next creation? Or is the act of awareness itself the point regardless of what it beholds? The answer may be beyond our reach, but the question itself changes how you see everything. Because if awareness is truly indestructible, then in some deep and literal sense, you will be here to see whatever comes next, even if you as you know yourself are long gone. Planck scale imprints, tiny structures that survive the end. What if, hidden beneath the smooth fabric of the universe we see, there is an unimaginably fine mesh, a grain to reality so small that even our most advanced microscopes of the mind can only guess at it? And what if this grain holds the most enduring fingerprints of existence? Structures so resilient they could outlast stars, galaxies, and even time itself. The Planck scale is the name we give to the smallest meaningful units of space and time, where the familiar rules of physics begin to collapse under the weight of quantum uncertainty, and distances become so tiny, 10 to the power of negative 35 meters, that the very notion of here and there starts to lose meaning. At this scale, space-time is no longer the continuous, smooth canvas described by Einstein's relativity, but more like a frothing sea of quantum foam, constantly fluctuating, warping, and reconnecting in wild, fleeting patterns. And yet, some physicists and theorists have begun to wonder, could certain patterns at this scale be stable, like knots in the deep fabric of reality, immune to the slow erasure that entropy inflicts on larger structures? If so, these Planck-scale imprints might be the ultimate survivors, the last relics of the universe when everything else has fallen to dust and radiation. In the familiar world, nothing lasts forever. Mountains crumble, atoms decay, even black holes evaporate given enough time. But at the Planck scale, our usual concept of decay may not apply. Here, the idea of time itself becomes ambiguous, and the smallest loops, twists, or informational encodings woven into the quantum geometry might be protected by the laws of physics, in the same way that certain mathematical knots cannot be untied without cutting the rope. If reality has such knots, they could persist through every phase of the cosmos: the fiery birth, the long expansion, the slow dimming, and even the final dissolution, emerging into whatever follows as seeds of a new order. This is not idle speculation. Some approaches to quantum gravity, like loop quantum gravity, and certain string theory frameworks, suggest that space-time is built from discrete, indivisible chunks of area and volume, and that these chunks can store topological information, the kind that cannot be erased by stretching or shrinking, only by tearing the fabric entirely. If that's true, then the universe might carry a hidden archive in its tiniest scales, one that records not the positions of stars or the orbits of planets, but deep structural codes, the primal blueprint of how reality can exist at all. These imprints could be the reason the universe has consistent laws across billions of light years, the reason particles behave the same way no matter where they are, the reason physics itself has memory. And here's the staggering thought. If such imprints are indestructible, they would not only survive the end of this universe, but they might also pass into whatever comes next, whether that's a reborn cosmos from a big bounce, a bubble universe budding off from quantum fluctuations, or something we cannot yet imagine. In that sense, they would be the DNA of reality. Not the DNA of life, but of existence itself, silently carrying the traits of all past universes forward into the future. The philosophical weight of this is immense. It would mean that while everything you know is temporary, the deepest foundation is eternal in a literal sense. Not just long-lasting, but immune to the very processes that define ending. In a heat-death scenario, where all particles decay into radiation, and even radiation fades into the background, the Planck scale imprints would remain, because they are not made of matter or energy in the conventional sense. They are the scaffolding that matter and energy require in order to exist. In a big crunch scenario, where everything collapses into extreme density, they would not be crushed, because they are already at the ultimate density limit. Even in the evaporation of black holes, where information loss is still debated, these imprints might act as the final carriers of whatever cannot be destroyed. And there's another layer. If the Planck scale is indeed the realm where quantum mechanics and gravity merge, then these imprints may not just store the architecture of space. They might store the architecture of possibility. That is, they could encode which forms of physics are allowed, which constants have meaning, and which configurations of particles can ever arise. If so, then the universe's choices. The fact that we have electrons and quarks, and not some entirely different zoo of particles, might be inherited from the imprints of a previous reality, just as the features of a child's face can echo those of a long-forgotten ancestor. This would transform the way we think about cosmic origins. The Big Bang would not be a clean slate, but the latest chapter in a story written in a language of geometric patterns far below the reach of light or matter. And if such patterns are stable, they may act as the ultimate book of memory, one that no catastrophe can erase. It is tempting to think of these imprints as unimaginably small, but perhaps small is the wrong word. They are fundamental, outside of scale as we normally use it. Because the Planck scale is not a location you can zoom into, but a limit beyond which zooming stops making sense. You cannot take a magnifying glass to these structures. They are the ground itself, the baseline upon which all magnification rests. And here is where the idea becomes truly disorienting. If these imprints are real, then in some sense you are made of them and always have been. Your body, your thoughts, your history are temporary configurations riding on a platform of patterns that predate you by billions of years and will outlast you by perhaps an infinite span. From that perspective, death, whether personal or cosmic, is less an annihilation and more a rearrangement, the falling away of transient shapes, while the underlying lattice remains. Mainstream science has yet to find direct evidence of such Planck scale structures, but the search is underway in subtle ways. High-energy physics experiments, looking for violations of Lorentz invariance, astrophysical observations, hunting for tiny dispersions in the arrival times of gamma ray bursts, and mathematical work probing whether spacetime's geometry can be quantized without contradiction. So far, the Planck realm remains hidden, but its possibility haunts every theory that tries to unify quantum mechanics and relativity, because without some deep structural resilience, it's hard to see how reality itself could survive the wild fluctuations it must have endured at the birth of the universe. If we ever do confirm these imprints, it would mean that the end is never truly the end, that beneath every collapse, every death, every silence, there is a foundation that persists, carrying the memory of all that has been and the potential for all that will come. And in that sense, the most important truth might be this: you are living right now on a stage whose floorboards are older than time, and will still be here when time is gone. A lattice of existence that does not know how to vanish. Relativity's final frame, the last possible moment of time. What if there is a final frame to the universe's story, not just the end of stars, galaxies, and life, but the last physically possible moment in which time can still exist? The ultimate boundary beyond which no clock can tick, no event can follow another, and the very idea of before and after dissolves into something our minds are not equipped to imagine. In Einstein's relativity, time is not a universal river flowing independently of the world. It is a dimension intertwined with space, stretched and compressed by gravity, bent and warped by motion, so that now for one observer is never exactly now for another. This flexible nature of time means that its flow is relative. But relativity also hints at something more profound. If the conditions are extreme enough, infinite gravity, infinite density, infinite curvature, the sequence of moments can, from at least some perspectives, stop entirely. In the core of a black hole, relativity predicts a singularity where space and time as we know them cease to be meaningful. Not because the clocks are broken, but because there is no next tick to measure. It is the edge of spacetime itself. The idea of a final frame takes this further. It asks whether the entire universe could approach a state where the unfolding of events slows, halts, and then cannot resume, not locally as inside a black hole, but everywhere at once. Imagine the cosmos as a vast film reel being projected, each frame a complete configuration of the universe, and time as the illusion of motion created by the rapid succession of those frames. In normal life, the frames flow so smoothly you forget they are separate. But what if there is a final frame, the last possible snapshot, after which no more are available? Not because the real ends in space, but because the underlying physics no longer permits change. This is not just science fiction musing. Certain cosmological models suggest that the universe could evolve toward states where the rate of change approaches zero. In a heat-death scenario, as energy differences disappear, there would be no processes left to distinguish one moment from the next. With no motion, no change, no interaction, time would have no reference points. And in a deep physical sense, it would lose all meaning. From the perspective of relativity, without change, the metric of time becomes irrelevant, and the final frame is the ultimate freeze. The whole universe suspended in an eternal static state. But other possibilities are even stranger. In some interpretations of cosmology, the accelerating expansion driven by dark energy could stretch space so violently that every region becomes isolated, and as the redshift of distant light approaches infinity, signals from other regions never reach us again. In the far future of such a universe, even inside our own cosmic island, particles could decay, and what remains could become so diffuse that the very concept of a clock, which depends on periodic processes, becomes impossible. A single oscillation of anything could take longer than the age of the universe itself, until eventually the concept of oscillation no longer applies. This is not simply slowness, it is asymptotic approach to stillness, where the next moment is so far away it may as well never arrive. Yet relativity also allows us to twist this idea in more shocking ways. In certain extreme gravitational scenarios, time for one observer could end, while for another it continues. If the whole universe collapsed into a final singularity, the opposite of heat death, a big crunch, then as the density approached infinity, the space-time curvature would become so severe that proper time for all observers would converge to a finite limit, the last frame. From inside, everything would seem to happen faster and faster as the end approached, a cosmic acceleration of events, until suddenly there is nothing left to happen. This final frame is not a moment you could see coming like a sunset on the horizon. Relativity would hide it in the same way it hides the inside of a black hole. For an observer in the distant past, the end might take infinite time to arrive, while for someone riding the collapse, it could happen in a heartbeat. And then there is the possibility entertained in certain speculative physics circles that the final frame has already occurred, that what we experience as time flowing forward is in fact a reconstruction of an already complete space-time block, and our consciousness is simply moving through the frames in order. In the block universe, interpretation of relativity, past, present, and future, all coexist in a four-dimensional structure, with time as we know it, emerging from our subjective traversal of this landscape. If this is correct, the final frame is not an event waiting for us, but a boundary that has always existed, part of the whole cosmic object. In that case, the universe's last moment is already there, fixed, as real as the moment you are in now. And your path to it is inevitable, like a bead sliding down a predetermined wire. The philosophical implications are unsettling. If there is a final frame, what lies beyond it? Relativity says, beyond has no meaning, because time itself is part of what ends. But our minds instinctively try to picture something. A blankness, a void, a silence beyond silence. And yet, in the same way that quantum physics allows for fluctuations in empty space, some have speculated that the end of one temporal sequence could be the seed of another, that the final frame could contain within its structure the conditions for a new beginning. If so, time might be cyclic on scales so vast that we cannot detect the repetition, with each cycle bounded by its own final and first frames, separated by states, in which time has no meaning at all. From a human perspective, thinking about the final frame can be both terrifying and clarifying. Terrifying, because it forces you to imagine not just your own death, but the death of every possible moment, the collapse of the very medium in which change and meaning exist. Clarifying, because it reminds you that all experience is bracketed. There is a first frame for each of us, and there will be a last, and that everything you are happens between those boundaries. Physics may one day tell us whether the universe will meet its end in fire, ice, or something stranger. But relativity already whispers the deeper truth. There is a limit, a last tick of the last clock. And after that, the stage, the actors, and the script vanish together. The universe's final frame will not fade to black. It will simply stop. And with it, the very possibility of anything ever happening again. Echo universe theory. We are hearing the reverb of creation's end. What if everything you see, hear, and feel right now is not happening in the raw, unfiltered present, but is instead the long, slow echo of an event so monumental that it ended reality as it was? And what we call the universe is merely the lingering reverb of that ending, stretched across the vast halls of space-time. The echo universe theory begins with a radical shift in perspective. Instead of thinking of the cosmos as an ongoing performance, unfolding in real time, it proposes that what we perceive as the living present is actually the aftersound of something that has already finished. The way a cathedral remains filled with the fading vibration of a single, long-lost note. In ordinary life, echoes are just delayed sound waves, bouncing off distant walls, carrying fragments of an original event into the moments after it has passed. In this cosmic analogy, the walls are the curvature and structure of space-time itself, and the original note was the final act of creation or destruction that brought the universe into the form we now inhabit. The idea draws on a subtle truth from both physics and perception. You never encounter reality instantly. Light takes time to travel, sound takes time to arrive. Even nerve impulses take time to reach your brain. Everything you experience is already in the past, sometimes by nanoseconds, sometimes by billions of years. The echo universe theory pushes this to the ultimate extreme. Perhaps there is no current universe at all, only the complex, overlapping after effects of its terminal moment, still traveling through a space-time whose own persistence is a kind of illusion sustained by the echo itself. In this framework, the cosmic microwave background, that faint omnipresent glow we interpret as leftover radiation from the Big Bang, is not the fossil heat of a birth, but the deep, low hum of a universe, that has already gone silent, its last energy still rippling outward in longer and longer wavelengths. The accelerating expansion we measure might not be the universe rushing apart in the present, but the geometry of an echo dispersing, the wavefronts of a single cosmic event, still bouncing through an arena that no longer has a source. This would mean that all cosmic structure, galaxies, clusters, filaments, are not ongoing constructions, but frozen artifacts illuminated by the last light they reflected before the end. Their positions and motions part of the echo's shape, rather than signs of continued activity, in the same way that a long, resonant gong tone contains within it all the harmonics and textures of the initial strike. The tone of our universe could be encoding every detail of that final event, its force, its duration, the instrument of physics that produced it. This raises a profound question. If everything is an echo, what happened to the source? Did the universe end in a collapse, a freeze, or a transformation so complete that its current appearance is just a ghost image of incompatible physics? Like the afterglow in your eyes when you look away from something blinding, some speculative cosmologies propose that universes are cyclical, each one born from the death of another. But in the echo universe model, there might be no next cycle until the echo fully fades. This opens an even stranger possibility that the echo is not just a passive remnant, but the active substrate of all existence, that we live within the memory of an ending, and that memory is coherent enough to act as a reality in its own right. The reverb analogy becomes more powerful here. In music, an echo is never a perfect replica of the source. It is altered by the surfaces it bounces from, stretched, distorted, its high notes lost first, while its bass lingers longest. If our universe is an echo, then what we think of as the laws of physics may be the distorted laws of a decaying pattern, not the full physics of the original event. That would explain why certain constants in nature, the speed of light, the fine structure constant, the cosmological constant, seem finely tuned. Perhaps they are the surviving harmonics of a more complex reality, the ones that could endure longest through the echo's decay. It might even explain the arrow of time. In a true present, time might flow in multiple directions, or not exist at all. But within an echo, there is only the direction of fading, from loud to soft, from bright to dim, from ordered to diffuse. That decay would feel to us like forward time. This theory also transforms the way we think about observation. In standard cosmology, when we look at a distant galaxy, we are looking back in time to when its light began its journey toward us. In the echo universe, we are looking into the resonance pattern, picking out one ripple among countless others, and mistaking it for an active, independent source. That ripple cannot change. It has already happened, but we can still receive and interpret it, just as a listener can still hear a note that has already been played. In this sense, the entire act of science becomes a kind of echo analysis, reverse engineering the nature of a source we will never directly witness. The philosophical implications are staggering. If this is true, then your life, your choices, even your thoughts are part of the echo's pattern. They are not new events in the absolute sense, but features that were already implicit in the original wavefront, unfolding inevitably as it passes through you. Free will, in this model, is the perception of novelty within a predetermined resonance, like a dancer improvising within the strict rhythm of a song whose tempo can't be changed. This does not make your experiences meaningless. In fact, it gives them a strange kind of immortality, because if you are part of an echo, you will last as long as the echo lasts, woven into the universal reverb. The ultimate question then becomes, how long can an echo last? In ordinary acoustics, echoes fade as their energy dissipates into heat. In the universe, the energy of the echo is stretched into longer wavelengths, spread over larger volumes, until it becomes indistinguishable from silence. If the expansion we observe is the stretching of this echo, then the fading might take trillions upon trillions of years, giving the illusion of a living cosmos for an almost unimaginable span. But eventually, if the analogy holds, there will come a moment when the wavelengths are so long, the energy so thinly distributed, that no structure remains, no contrast to mark the difference between one moment and the next. That would be the end of the echo, the final vanishing of the last vibration. And with it, the end of all apparent reality. Yet perhaps there is one more twist. In certain resonance systems, an echo can feed back into itself, bouncing in such a way that it creates a standing wave that never truly dies, sustained by the geometry of the medium. If spacetime itself has such a geometry, the universe's echo might not fade completely. Instead, it could loop endlessly, the same patterns recurring over and over, identical down to the smallest detail. From within, you would never know. You would simply experience life as if it were unfolding for the first time, unaware that it was the trillionth pass through the same vibration. This could be the ultimate prison or the ultimate stability, depending on your point of view. Either way, the echo universe theory forces a radical humility. What you call the present may not be a fresh living moment at all, but a note played long ago, still shivering through the architecture of existence. Its source forever silent, its music slowly unraveling into the dark. Information cannot die. Physics of memory beyond the big freeze. What if the most indestructible thing in the universe is not matter, not energy, not even space-time itself, but information, the raw pattern of how things once were? And what if, even in the most distant and frozen future, when every star is dead, every atom dissolved, and every black hole evaporated, that information still remains, woven into the fabric of reality in ways that no force of nature can erase? This is not just poetic speculation. It is a principle embedded in the deepest laws of physics, whispered by quantum mechanics, shouted by thermodynamics, and defended fiercely by some of the greatest minds of modern science. That information cannot be destroyed, only transformed, scattered, and hidden. In the classical view of the cosmos, the heat death, or big freeze, paints the bleakest possible future, trillions upon trillions of years from now. Every usable energy source spent, all matter decayed into a thin soup of elementary particles, the temperature of space approaching absolute zero, and no events left to mark the passage of time. To the human imagination, this sounds like the end of everything. But in the quantum view, even that silent void must carry the imprint of all that has come before, because every interaction, every entanglement, every ripple of a particle's wave function leaves behind a trace. And the laws governing these processes are reversible at the fundamental level. If you could, in theory, measure every subtle correlation between every surviving particle and photon in that frozen future, you could reconstruct the story of the entire universe, from the birth of the first stars to the thoughts you are having now. This is the essence of the principle. Physics allows for scrambling and dispersion of information, but not for its annihilation. It is why the black hole information paradox became such a central puzzle. Stephen Hawking's early work suggested that anything falling into a black hole would be lost forever, replaced only by featureless radiation as the whole evaporated. But this clashed with quantum theory, which insists that the wave function's evolution is unitary, meaning it never discards information. Decades of debate led to the holographic principle, a radical idea that the complete description of everything within a region of space can be encoded on its boundary surface, like a cosmic hard drive. In this view, even as a black hole shrinks and vanishes, the information about what fell in is somehow preserved in subtle correlations in the radiation it emits, scrambled beyond recognition, but still there. Now take that principle and apply it to the entire universe. The Big Freeze is not a bonfire of existence, but a vast, cold archive. Every interaction that ever happened has left an indelible mark in the quantum state of the cosmos, and the final state is not blank, but maximally entangled, saturated with the ghosts of every pattern that ever was. The idea becomes even more bending when you realize that information in physics is not just data in the human sense, not just words, images, or measurements, but the total arrangement of all degrees of freedom in the system. A single photon, its polarization subtly shifted by scattering off an atom billions of years ago, carries part of that record. A lone neutrino drifting through intergalactic space might bear a fragment of the imprint of a supernova long extinct. Even the quantum vacuum itself, the seething background of virtual particles and fields, may store correlations that connect back to the earliest moments after the Big Bang. In this light, the end of the universe is not a blank page, but a page so densely written that we can no longer read the letters. And here comes the paradox that forces you to think differently about endings. If information cannot die, then the past cannot truly vanish. It can be hidden. It can be scattered so widely that no physical being could ever collect it, but it is still there. The question then becomes, not will anything survive, but in what form will survival occur? The answer may be stranger than we expect. In the heat death, the remaining particles and photons are so dilute that interactions become unimaginably rare. And yet those very particles carry within their collective quantum state the memory of the universe's entire history. In principle, an unimaginably advanced intelligence, with tools capable of manipulating entire galaxies' worth of matter and energy, could over vast epochs sift through the cosmic debris and decode those memories, like archaeologists reconstructing a city from a billion scattered grains of dust. Some physicists even speculate that the laws of physics themselves may be nothing more than a kind of long-term memory, a stable informational pattern that persists through cosmic evolution. This would explain why the constants and symmetries we see today are the same ones that shaped the early universe. They are the persistent settings of reality immune to decay, because they are woven into the fundamental information structure. If that is true, then not only the story of the universe, but the rules of its storytelling are immortal. But there's another, more unsettling implication. If information cannot die, then every moment is, in a sense, still. There's somewhere in the state of the universe, preserved forever. The you of right now is not just a fleeting configuration. You are an eternal pattern embedded in the whole. That pattern may never be reassembled in practice, but it exists in principle and in physics. In principle is enough to make it real. In this way, immortality is not a matter of consciousness persisting, but of the impossibility of your pattern's erasure. You may be gone, but the record of you remains, written into the structure of reality as deeply as the laws themselves. Critics sometimes argue that in the heat death, any access to this information would be forever impossible, because it would be so scrambled and diluted that no process could reverse it. And perhaps that's true for beings like us. But the principle remains: what has been cannot be unmade. Even if no one ever reads the archive cannot be destroyed. This is the universe's ultimate form of memory, passive, complete, and eternal. It transforms the meaning of the end. The big freeze is not a curtain falling on a stage that is then dismantled. It is the curtain freezing in place, the set remaining forever in the position it held at the last moment. Every detail preserved in the crystalline stillness of a cosmos without change. And if information is indeed eternal, then the birth of our universe was not the ultimate beginning. It was the continuation of a chain of informational states stretching back beyond what we can imagine. Our universe's initial conditions were themselves the output of some prior informational configuration, perhaps from a previous cosmos, perhaps from a deeper substrate that is not born or destroyed, but only changes shape. This hints at a view of reality in which there is no absolute creation or destruction, only an infinite dance of transformation within an unbreakable informational web. From this perspective, even the ultimate doom of stars and atoms loses some of its sting, because nothing of what they were is ever lost. The end of the universe is simply the final update to the record, after which no more entries are made, but all entries remain. You live, then, in a world where forgetting is impossible, not for you, but for the cosmos itself. And that means your existence is as indelible as the laws that govern it. a pattern that will outlast time. Multiverse leftovers. Cross-bleed from universes that have died. What if the strangest phenomena we see in our cosmos, unexplained forces, odd alignments, bizarre energy imbalances, are not born here at all, but are the faint scraps and lingering embers from entirely different universes? Ones that have already run their course and died, leaving only a faint cross-bleed of their final moments into ours. The concept of the multiverse often focuses on the idea of many universes existing simultaneously, separated by vast gulfs of dimension or by the impermeable walls of different physical laws. But the multiverse leftovers hypothesis turns the question sideways. What if the boundaries between universes are not perfect, and when one universe collapses, decays, or transforms, something of it leaks through, like smoke seeping under a door into another room, in the same way that a dying star can scatter its elements into interstellar space to seed new generations of planets? Perhaps an entire universe, in its final convulsions, can scatter deeper relics, not just matter and energy, but patterns, distortions, and informational imprints into the neighboring layers of reality. Our universe could be the quiet recipient of such debris, inheriting subtle features from the demise of realms that no longer exist, their fossils embedded invisibly in the constants of our physics, the structure of our vacuum, or the geometry of space-time itself. Some cosmologists have considered that the vacuum of space, far from being an empty void, is an ocean of fields and fluctuations, restless even in its lowest energy state, and that its precise properties, the strength of quantum jitters, the balance between forces, could be the residue of prior cosmic configurations. If a parent or sibling universe with slightly different constants were to dissolve, the collapse of its field structure might bleed into ours, adjusting the fine tuning of our own vacuum ever so slightly. The outcome would be a cosmos whose deep rules are not entirely self-born, but a patchwork quilt sewn from the remains of many predecessors. This idea is not entirely alien to certain versions of eternal inflation theory, in which bubble universes continuously form and expand in an ever-growing multiverse. If bubbles can nucleate, they might also decay, and their decay products, whatever survives the annihilation of their space-time fabric, could drift into the still, growing domains of other bubbles. In that case, we might already be swimming in the diluted remains of universes that popped into existence, lived through their own histories, and died billions of multiversal years ago. And just as in archaeology, where the oldest fragments are often the most eroded and unrecognizable, these crossbleeds would be faint, distorted, stripped of the context that could tell us what they originally were. Perhaps the cosmological constant that drives our universe's accelerated expansion is in part the leftover energy of some prior universe's catastrophic collapse, an echo not of our own Big Bang, but of an ending we never witnessed, or perhaps certain large-scale anomalies in our cosmic microwave background, those odd cold spots and alignments that stubbornly resist conventional explanations, are not the fingerprints of our own birth, but scars left by the ghostly collision of our early universe with the dying wavefront of another's demise. The idea forces you to rethink cosmic inheritance. What if even the matter we are made from is second-hand in the most literal sense? Atoms forged not in the stars of our own cosmos, but in the last days of an entirely different one, surviving the passage between universes, because some principles, like conservation of information, are not confined to a single reality. In such a scenario, our periodic table could be a universal palimpsest, each element carrying a history that extends beyond the life of this cosmos, its protons and neutrons assembled from a supply chain older than our Big Bang. More unsettling still is the possibility that leftovers from other universes are not just inert debris, but active influences, seeds that can alter the trajectory of our own cosmic evolution. A stray field configuration drifting in from a dead universe might act like a foreign gene in a living organism, subtly rewriting our own physics to accommodate its presence. Over unimaginable spans of time, such insertions could accumulate, making our universe less a purebred creation and more a hybrid, its laws, the blended outcome of countless predecessors. If so, then the multiverse is not a neat collection of sealed, off realities, but a dynamic ecosystem with births, deaths, and exchanges, where the story of any one universe cannot be told without the ghosts of many others. This idea also reframes the mystery of why the universe appears so improbably fine, tuned for complexity and life. Perhaps it is not because our cosmos was born perfect for these conditions, but because it is the product of long multiversal evolution, inheriting advantageous traits from those that came before, traits that survived the end of their original homes, because they were encoded in the most resilient substrate of all, the structure of existence itself. Philosophically, the thought is dizzying. You are not just a child of the stars in your own universe, but a descendant of events and patterns that unfolded in alien realities, long dead and perhaps unimaginably different, yet close enough in the deep topology of the multiverse to leave their fingerprints on you. Even your thoughts, in this framing, are ripples in a sea whose currents were stirred before your cosmos existed, shaped by legacies you will never fully trace. If physics one day finds evidence of such leftovers in the form of statistical anomalies, unexplained symmetries, or energy signatures that defy our cosmological models, it would mean that the boundaries of our history are not where we thought they were. The Big Bang would no longer be the clean starting point of everything we are, but merely the most recent chapter in an endless exchange of births and deaths, each universe donating something to the next. And the greatest irony, the dead universes, whose remnants we detect, might themselves be composites, their own physics, stitched together from the debris of even older worlds. In that sense, reality may have no true beginnings at all, only inheritances upon inheritances, an infinite chain of creation through recycling, where nothing is ever wholly new and nothing is ever wholly gone. You live then in a cosmos that is not a self-contained masterpiece, but a vast, intricate collage, and every atom of you is a page torn from a book whose language you will never fully learn, written in universes whose stars have long since gone dark, the silence between universes, experiencing the gap after the end. What if, after the last star in a universe burns out, after the final particle decays, after the last ripple of light stretches beyond any hope of detection, there is not immediate nothingness, but a pause, a gap between realities so absolute that it is not made of space, not measured by time, and not filled with anything at all, a silence so pure that it erases even the concept of silence. We tend to imagine the end of a universe like a door slamming shut and another opening, or like a dying ember sparking a new flame. But what if there is a vast, unbridgeable interval in which no before and after exist, an in-between where the machinery of reality is not merely inactive but absent? This is the essence of contemplating the silence between universes, a state beyond death where not even emptiness remains, because emptiness itself is a property of space, and in the gap there is no space to be empty. In our current understanding of cosmology, the possible fates of the universe, heat death, big crunch, big rip, all describe transformations of space-time from one condition into another. But they rarely address the possibility that there could be a total discontinuity between one universe's end and whatever follows. If space-time itself has an origin and a termination point, and if those points are genuinely the boundaries of existence, then beyond them, there is no location for anything to be, no moment in which anything could happen. The closest analogy is not death, but the unmeasurable interval between two separate dreams, the unrecorded blankness that lies outside the narrative of both. In quantum cosmology, there are models in which universes are born from quantum fluctuations in a deeper meta-reality, like bubbles appearing and disappearing in a sea of potentiality. But even in those scenarios, the sea is still a form of existence. The silence we are speaking of here is more radical. It is not the ocean, it is the absence of water, absence of seabed, absence of the very idea of wetness. It is an ontological vacuum, where not only are there no objects, there is no framework for objects to exist. And yet, we cannot help but wonder, if such a gap exists, could it be experienced? The mind revolts at the thought, because experience requires change, and change requires time, and in the gap there is no time. But what if awareness, in some fundamental form stripped of memory, identity, and sensation, could persist independently of space-time? If so, then encountering the silence between universes would not be like floating in darkness. It would be like being suspended outside all contrasts, with no now to follow a then, no reference point by which to measure that it is happening at all, to any consciousness within it. The gap might be instantaneous and eternal at once, an unbroken non-event that cannot be described in terms of duration. Physically, this gap could be the non-region that separates the final state of one universe from the initial conditions of the next, a kind of causal quarantine that prevents direct contamination between realities. If universes are like self-contained computational processes, then the silence could be the moment the old program fully halts. The processor clears its registers, and only then is a new process allowed to begin. In this sense, the gap is necessary, a reset to zero, not just in content but in context. And if information truly cannot be destroyed, as quantum theory suggests, then the silence might serve as a perfect archive, locking away the totality of a universe's history in a form that is forever inaccessible to the next one. This would make each universe a discrete chapter in a book that can never be reread, with a blank page between chapters being the silence itself. Some speculative theories in loop quantum gravity or cyclic cosmology imagine that universes can bounce from one phase to another without ever passing through a true void. But if this gap exists, it is the antithesis of a bounce. It is a severance, a clean break in the continuity of existence. The fact that we can even contemplate it may say more about the human brain's compulsion to fill in blanks than about reality itself. Because strictly speaking, there is no in the gap. There is only the total absence of in. And yet, consider how many mysteries in physics arise from boundaries. The Planck time at the universe's birth, the event horizon of a black hole, the limits of the observable cosmos. In each case, we are confronted with an edge beyond which our definitions fail. The silence between universes would be the ultimate edge, not an edge in space, not an edge in time, but the edge of being itself. From our perspective inside a functioning universe, it is impossible to know whether this silence is featureless, or whether it holds, in some latent form, the potential for the next universe's birth. If it is truly nothing, then the next universe emerges from no cause at all, a pure spontaneity that violates our every intuition. If it is not nothing, then it must be something so unlike the somethings. We know that calling it anything is already a distortion. Perhaps in that gap, there exists a kind of pre-geometry, a structureless field of possibility that is not space and not time, but from which space and time can crystallize. If so, then the silence is not sterile but pregnant, not an absence, but a stillness before a new storm. The philosophical implications are dizzying. If there is a silence between universes, and if some form of awareness can endure through it, then in some sense, there is no true death, only intervals. But intervals without markers are indistinguishable from non-existence. So to pass through such a silence would be to vanish completely from any frame of reference, only to reappear when a new frame forms. It would be a kind of reincarnation stripped of continuity, where the you that awakens in the next universe has no memory of having waited in the silence, because there was nothing to remember. This makes the gap both a boundary and a bridge, a point of absolute disconnection, and yet the only path from one reality to another. If, on the other hand, no awareness can survive the end of a universe, then the silence is utterly uninhabited, a true void that serves no witness. In that case, it exists only from the outside, a feature of the multiverse's architecture that no inhabitant of any single universe will ever encounter. And yet, Even in that sterile interpretation, the silence plays a crucial role. It ensures that the identity of each universe remains pure, that the constants, laws, and histories of one cannot bleed into the next. It is the firewall between realities, and without it, the distinctiveness of each cosmos might be impossible. To think of such a silence is to confront the limits of our capacity for imagination. We can imagine emptiness, we can imagine darkness, we can imagine even the absence of form. But to imagine the absence of space, time, and possibility is to try to see with no eyes, to listen with no ears. Perhaps the truest way to approach the silence between universes is to admit that it cannot be approached at all, that it is the one place where our questions cannot follow, and yet, the very existence of the question changes how we see the present. It reminds us that what we call reality is itself a bounded condition, with a beginning that emerged from something beyond it, and an end that will give way to something beyond it again. Even if that something is a silence so deep, it cannot be told from nothing. The universe you know is framed on both sides by mystery, and the silence between universes is the most radical of them all, the pause in the cosmic symphony where no notes are played, yet from which the next movement will inevitably begin. Light travel delays. Why we might be watching a universe long dead. What if every glittering star, every spiral galaxy, every vast cluster of light you see in the night sky is nothing more than the preserved image of something that has already ceased to exist? The last visible signature of a cosmos that might have gone cold, collapsed, or transformed beyond recognition billions of years ago. And what if the reason we think the universe is alive and expanding is because light takes time to reach us, and we are looking not at reality as it is, but at a cosmic graveyard preserved in motionless photographs? Light, no matter how fast, is not instantaneous. It moves at a fixed speed of about 299,792 kilometers per second, which sounds impossibly quick until you consider the distances it must travel. The moon's glow is 1.3 seconds old when it reaches you. Sunlight is 8 minutes old, and the light from the nearest star beyond the Sunday is more than 4 years old by the time it enters your eyes. These delays are trivial when compared to the scale of the universe. The Andromeda Galaxy's light is already 2.5 million years old, meaning that when you look at it tonight through a telescope, you are seeing photons that began their journey when early humans were still using stone tools. Push this further, and the farthest galaxies in the Hubble ultra-deep field appear as they were more than 13 billion years ago, not because we are peering into their present, but because their present hasn't had time to arrive. And here lies the unsettling core of the thought. If light is the only messenger that tells us what is out there, and it is always late, then we have no knowledge whatsoever of the current state of the distant universe. Only a patchwork of ancient snapshots layered over one another, each one frozen at a different point in time. This means that the farther away an object is, the further back into history we are looking. And by the time we stitch together a map of the cosmos, we are assembling an image of a world that no longer exists anywhere but in the light itself. In extreme cases, entire galaxies could have collided, stars could have burned out, black holes could have swallowed everything in sight, and new structures could have formed in the billions of years since their light began the journey to us. Yet for us, those events haven't happened, because their photons haven't yet reached Earth. In this sense, astronomy is not the study of the universe's present, but the archaeology of its light, digging through layers of time instead of soil. The eerie part is that we have no way to know which parts of our cosmic picture are still real, and which are merely relics. Our telescopes are time machines, but only in one direction, backward. Now consider what this implies for the universe as a whole. In our current models, the cosmic web of galaxies is dynamic, constantly changing, but our view is smeared across 13.8 billion years of light. Travel delays. We might be living in a region of the universe that is still active and full of stars, while vast swaths of space beyond our observational reach have already gone dark. Their last photons still on their way. Worse, because the universe is expanding, and the rate of that expansion is accelerating due to dark energy. Some of those photons will never arrive at all. The so-called cosmic event horizon marks the ultimate limit. Any galaxy beyond it is forever cut off from us. Not because it doesn't emit light, but because the space between us and it is stretching faster than the light can close the gap. It's possible that entire regions of the universe have already passed beyond that horizon, meaning that their last light has already been launched, and, after it arrives, no further updates will ever follow. One day, those regions will fade from view entirely, not because they cease to exist at the moment they vanish, but because we have reached the end of their visual history. This slow erasure means that the visible universe is shrinking in terms of what we can actually see, even as it physically grows. The deeper truth here is disturbing. There is no single now across the cosmos. Relativity tells us that simultaneity is relative. What is happening right now in a galaxy 10 billion light years away is not a question that even has a clear meaning for us. Because by the time light from that moment arrives, our own now will be billions of years in the future. In practical terms, the universe you think you inhabit is a palimpsest of many different pasts, stitched together by your perception into a single whole. The Big Bang itself is not something you could ever see happening. All you can see is its afterglow in the form of the cosmic microwave background, an image of the universe when it was Fei years old. That image is Fei billion years out of date. Yet it is the only glimpse we have of those early conditions. Everything we know is like this, a collection of delayed signals, each one a frozen moment long gone. And if this is true, then here is the most staggering possibility. The universe could already be dead. Its stars could be extinguished, its matter decayed into radiation, its expansion complete, and we would still see it as vibrant and full of galaxies, because the light from its younger, living self is still flooding toward us. We would, in effect, be inhabiting a kind of cosmic memory walking through a museum whose exhibits are still lit, even though the building has already collapsed in another part of time. This idea reframes every image from the James Webb Space Telescope and every distant supernova we record. They are not out there in the way we think. They are preserved moments in flight, messengers from a past that will never repeat. The philosophical consequences are just as deep as the physical ones. If everything we see is an old version of reality, then the present is unknowable on cosmic scales. It exists for us only locally, and even then with a delay measured in tiny fractions of a second. On a universal level, now is an illusion stitched together from billions of different latencies. That means when you look at the night sky, you are not seeing where things are, but where they were, and the distance to an object is also a distance in time. The farther you gaze, the more you are removed from the present, until at the very edge of visibility you are staring at a universe so young it barely had stars at all. And yet, there is something profoundly beautiful about this. The light that falls on your eyes tonight has traveled unbroken for millions or billions of years, surviving every hazard of deep space to carry you a story no one else can see in exactly the same way. You are not just an observer, you are the final destination of that photon's entire existence. In that moment, the dead past becomes alive again, not in its original form, but in your perception of it. The tragedy, of course, is that there will come a time when fewer and fewer of those messengers arrive. As the universe ages, galaxies will drift beyond our event horizon, and their light will cease to reach us, leaving only the local group, a handful of galaxies bound together by gravity, as the last luminous islands in a growing ocean of black. Eventually, even they will burn out, and the only light left will be the faint glow of fading remnants, stretched into wavelengths too long for any eye to see. But for now, every star you see is a letter from the past. Every galaxy a time capsule, and the whole sky is a library of ancient chapters, each one already closed, yet still being read. In that sense, we are the last audience of a play whose final act may have been performed long ago. and the curtain we fear has not yet fallen. Not because the performance continues, but because its light is still on the way. Entanglement beyond death, quantum links that outlast the cosmos. What if the deepest connections in the universe, the ones that bind particles together in ways so complete that they share a single quantum state, do not vanish when the objects themselves are destroyed, when the stars they came from fade, or even when the universe that once held them collapses into its final breath, but instead persist as invisible threads stretched across realities, outlasting the cosmos itself. Quantum entanglement is already one of the strangest and most unsettling discoveries in physics, showing us that two particles can become so linked that no matter how far apart they are, across a lab bench or across billions of light years, a change to one is instantly reflected in the other, as if space and time simply don't apply to their relationship. In experiments, this effect has been proven over and over again. Entangled photons, electrons, and even larger molecules behave as if they are parts of a single system, their fates inseparable, their information bound together in a way no classical signal could explain. But most discussions of entanglement stop at the boundaries of the experiment, as if the link exists only as long as the particles themselves persist in recognizable form. The possibility that entanglement could outlive not just the particles, but the physical structures of the universe that once contained them, pushes us into a realm where even death, whether of matter, stars, or space-time itself, is no longer the final eraser. To understand how this could be, you have to step away from thinking of entanglement as a fragile, magical connection that can be cut when something is destroyed. In quantum theory, entanglement is not a physical tether, but a correlation in the fundamental wave function of reality itself, an embedding of information into the total state of the universe. When two particles become entangled, they cease to have independent descriptions. Instead, the description of the whole system encodes their relationship. If one particle is destroyed, scattered into other particles, absorbed into radiation, even swallowed by a black hole, the quantum correlations that defined its relationship to its partner do not vanish. They are redistributed into the larger system. This means that, in principle, the link is not broken, but becomes woven into the fabric of whatever remains. Now take that principle and imagine it scaled up to cosmic history. The early universe, moments after the Big Bang, was a cauldron of interactions. Particles constantly colliding, annihilating, forming and reforming, creating a vast, intricate network of entanglements. Every interaction left its imprint, and because there is no global eraser in quantum mechanics, those imprints still exist, diffused and scrambled though they may be. As stars formed and died, as galaxies collided, as black holes consumed matter, and then evaporated, the entanglement web did not unravel. It simply became more complex. Its information smeared across more and more degrees of freedom. In this picture, the universe is less a collection of separate objects and more a single incomprehensibly large quantum state, with correlations stretching between regions that will never see each other again. And here's the extraordinary implication. If the end of the universe comes, whether by heat death, big crunch, big rip, or some other fate, the final state will still preserve, in some form, the total entanglement history. Even if every atom decays into radiation, even if space-time itself is warped beyond recognition, the wave function describing everything still contains those correlations. They may be hidden in ways that no being within the universe could decode, but they are not gone. This is the same principle that drives the black hole information paradox. Stephen Hawking's early calculations suggested that anything falling into a black hole would be erased from the universe's records. But later developments, bolstered by the holographic principle, suggest that the information is preserved, encoded in subtle correlations in the Hawking radiation that escapes. If black holes, the most destructive entities we know, cannot erase entanglement, then perhaps neither can the death of the cosmos itself. The philosophical consequences are staggering. If entanglement outlives the cosmos, then in some sense, nothing is ever fully lost. Not your atoms, not the particles that once made you, and not the quantum relationships those particles had with the rest of reality. This is not immortality in the personal sense. The patterns that defined you may be so deeply scrambled as to be unrecoverable, but it is a kind of immortality of connection, a guarantee that the relational threads tying you to the rest of the universe are eternal, embedded in the final state of existence. And if there is a next universe, whether emerging from the ashes of this one in a cosmic bounce, or born as a fluctuation in some deeper meta-reality, those threads could, in principle, carry over. They might not reassemble into recognizable forms, but they could influence the structure, constants, or symmetries of whatever comes next, meaning that traces of our universe's entanglement network might seed the physics of its successor. More provocatively, some theorists have speculated that entanglement itself could be the engine of spacetime, that the geometry of the universe emerges from the pattern of quantum correlations rather than existing independently of them. If that's true, then the persistence of entanglement beyond the death of spacetime could mean that the capacity for space and time themselves to exist is never fully extinguished. The death of the cosmos would not be the end of the entanglement web, but a phase change in its form, perhaps collapsing into a more fundamental state from which a new geometry could emerge. This raises the mind-bending possibility that rare birth of a universe is not the creation of something entirely new, but the unfolding of an already existing web of correlations into a fresh stage. It would also mean that universes are never fully separate, that even across what we think of as cosmic death, there could be continuity of structure at the quantum informational level. And here is where the concept becomes almost mystical. If entanglement truly underlies space-time, then the beyond that exists after a universe dies is not nowhere, but the network itself, an abstract, a temporal fabric in which every correlation still exists, waiting for the next phase of expression. From the inside, that would feel like nothing. From the outside, if such a perspective exists, it might be the most intricate object imaginable, a perfect and eternal record of everything that ever happened, preserved not in pictures or words, but in the very arrangement of possibility. The challenge, of course, is that we cannot access these ultimate correlations directly. Decoherence, the process by which quantum systems become entangled with their environments, in ways that make interference effects vanish, hides them from us, burying them under layers of apparent classical reality. But the fact that we cannot see them does not mean they are gone. It means we are inside them. Every action you take, every photon that bounces off you, every gravitational tug you exert on distant matter is an update to the universal web. You are not just in the universe, you are a strand in its eternal quantum tapestry. And if that tapestry survives the collapse of the loom itself, then, in the most literal and physical sense, allowed by our current understanding of physics, you will never be entirely gone. When the final star burns out, when the last black hole fades, when even the fabric of space-time cools to stillness, the web will remain invisible, inaccessible, yet complete, holding within its structure the memory of every bond ever formed, every particle ever linked, every part of reality that was ever aware of any other. If that is true, then the cosmos does not end with death. It ends with the quiet persistence of connection, a lattice that no fire can burn, no ice can crack, and no void can erase. In that sense, the final fate of the universe is not destruction, but perfect preservation. And the final truth is not separation, but an unbreakable, everlasting entanglement. The recursive memory paradox, remembering a universe, remembering itself. What if the universe is not merely unfolding events across time, but is also in a strange and layered way remembering itself? Not as a single act of recollection, but as a recursive process, where each memory contains a memory of itself being remembered, spiraling endlessly inward like a hall of mirrors, in which every reflection holds yet another reflection, each one slightly altered by the act of seeing. The recursive memory paradox begins with the realization that memory, whether in a human brain, a computer, or a physical system, is never just a passive record. It is an active reconstruction. In neuroscience, when you recall something, you do not retrieve a perfect copy of an event. You rebuild it from stored patterns. And in doing so, you embed the act of recall into the memory itself. The next time you remember it, you are remembering not just the event, but the previous act of remembering, with all its distortions and biases layered in. Now imagine applying this principle to the entire universe. Every process in physics leaves an imprint. Gravitational waves ripple outward from massive events. Photons scatter with traces of where they've been. Quantum states entangle and carry correlations that persist across vast spans of space and time. The cosmos, in this sense, is constantly writing its own autobiography into the state of its matter, energy, and fields. But here's the twist. When any part of the universe interacts with another, when a particle absorbs a photon, when a star's light is captured by a planet's atmosphere, when your eyes take in the glow of a galaxy, the information from the past is not just stored, it is woven into a new state that now also contains a record of that storage. This means that the memory is no longer just about the original event. It also encodes the fact that the memory has been accessed. Just as a book with marginal notes reveals not only the text, but the reader's engagement with it. Over cosmic time, this becomes recursive. The universe contains a record of itself, and that record contains a record of the record, and so on, like a digital file endlessly resaved with the previous version embedded inside. At small scales, this recursion is buried in quantum correlations and thermodynamic traces. At large scales, it manifests in the layered structure of cosmic history, where each generation of stars carries the chemical signatures of the ones before. Each galaxy's shape reflects its history of mergers, and even the cosmic microwave background, the earliest visible photograph of the cosmos, has been reinterpreted, gravitationally lensed, and altered by billions of years of subsequent structure. So that what we see now is not the original image, but the original image, as remembered through the intervening universe. The paradox emerges because memory, in both cognitive and physical systems, is not static. It changes with each act of recall. In the human mind, this leads to the well-documented phenomenon that recalling a memory can make it less accurate over time. In the universe, the same principle could mean that the cosmic record is constantly rewritten by the very processes that access it. Photons bent by gravity, particles scattering off dust, observers measuring signals. The more the universe remembers itself, the further it may drift from the pristine original. Yet those drifts are themselves preserved, creating a deeper, more tangled memory. Eventually, you could reach a point where what is remembered is less about what originally happened, and more about the vast web of prior remembrances. A history of history, an echo of echoes. And here's the truly dizzying implication. If the universe is a closed system, then all acts of remembering, whether through physical interaction or conscious observation, are themselves part of the universe's state. Which means the universe is not just remembering events. It is remembering that it is remembering them. This feedback loop could, in theory, create self-reinforcing structures of information, patterns that persist, not because they are original truths, but because the act of recalling them is encoded again and again, making them ever harder to erase. In this way, the universe could preserve certain memories, far longer than the raw physical processes that created them would seem to allow, simply because those memories are embedded recursively in other memories. Now, consider what this means for us as observers. When you look at the night sky, you are not seeing the real Andromeda galaxy. You are seeing the light that left it 2.5 million years ago, which has been bent, scattered, and altered by intervening matter, then captured by your eyes and translated into neural signals. You are remembering Andromeda through the universe's own layered memory, and your observation becomes part of that memory for the future. In principle, a civilization billions of years from now could detect the faint traces of our telescope's observations in the altered states of the photons and particles we have already touched, reading in them not just the galaxy, but the fact that we once looked at it. This makes every act of perception an act of co-authorship in the cosmic archive. But it also raises an unsettling possibility. If memory is inherently recursive, then there may be no true original to recover. Every attempt to reconstruct the past, whether in a brain, in a fossil record, or in the cosmic background radiation, is reconstructing a reconstruction, an infinite regression where the past is always refracted through the lens of its prior recollections. In physics, this would mean that the initial conditions of the universe, the beginning, may be permanently obscured by the countless layers of its own self-memory. Even if we could, in theory, unwind all the interactions and correlations to their starting point, we would still be unwinding the universe's history of remembering that point, not the point itself. This is where the paradox cuts deepest. If the universe can only know itself through its own memories, and those memories are always altered by the act of remembering, then the universe can never have an unmediated knowledge of its own origin, and neither can we. The recursion becomes both the mechanism of preservation and the source of distortion. Yet perhaps this is not a flaw, but a feature in living systems. Recursive memory allows for self-awareness, the ability to not only store information, but to reflect on the fact of storing it. If something analogous operates at the cosmic scale, then the universe is not just a vast physical process, but, in a strange way, a self-reflective one. Each galaxy, each star, each conscious mind might be a node in a network, through which the universe experiences its own state. Not in real time, but through the endlessly folded layers of its self-memory. The truth of the universe, then, would not be a single fixed thing waiting to be uncovered, but the evolving sum of all its remembrances, a living archive whose contents are inseparable from the act of archiving. This changes how you might think about your own place in it. Your memories are part of the universe's memory, and your memories of remembering are part of its recursive loops. You are not outside the process looking in. You are a layer within it, as entangled with the past and future as any photon in a cosmic web. And if this recursion is truly infinite, if each memory contains the memory of itself being remembered, then in some profound sense, nothing is ever fully gone, because every layer still holds all the layers beneath it. The past is never just past. It is always present in the act of being remembered, even if that remembrance is imperfect. In this light, the universe may never truly forget itself, even if it can never fully know itself either. An eternal mind palace built of echoes, reflections, and the unending spiral of its own memory. Your existence as proof, consciousness as the final evidence of reality. What if the only undeniable proof that anything at all exists is the simple, irreducible fact that you are aware right now that no matter what science discovers about the origins of the universe, the structure of matter, or the fate of time, the most unshakable evidence for reality is not written in the stars, but in the raw immediacy of your own conscious experience. This idea that your awareness is the final evidence forces you to turn the searchlight of understanding inward, because while everything else in the cosmos can be doubted, simulated, or reinterpreted, the experience of being cannot be an illusion to the one having it. Even if the entire external world were a perfect simulation, even if your senses were feeding you a fabricated universe, the fact that you are experiencing anything at all would remain undeniable. Philosophers have circled this truth for centuries. From Descartes' cogito, ergo sum, to modern theories of consciousness, but most stop short of treating it as the foundational proof of reality itself. In physics, reality is typically defined in terms of measurable phenomena, but measurements require observers, and the act of observation is inseparable from awareness. This is not to say that consciousness creates the universe in the naive sense of mind over matter, but that the very recognition of a universe requires consciousness as its stage. Without an observer, existence might still unfold, but it could never be confirmed. You can imagine a universe without life, without matter, even without space as we know it. But you cannot meaningfully imagine a proof of its existence without some form of awareness to register it. This flips the scientific hierarchy on its head. Instead of consciousness being a late byproduct of cosmic evolution, it becomes the precondition for any claim about reality to hold meaning at all. Now consider what this implies for the deepest mysteries of existence. Physics seeks to describe the laws that govern the universe. But no set of laws can explain itself without presupposing that there is a mind capable of apprehending them. Even the most complete theory of everything would still be a structure of symbols and relationships, inert until interpreted by awareness. This is the invisible foundation beneath all scientific inquiry, the observer's undeniable presence. And here is where the idea grows more unsettling. If consciousness is the ultimate proof of reality, then what exactly is it? Neuroscience can correlate experiences with brain activity, but correlation is not identity. Knowing which neurons fire when you see the color red does not explain why there is something it is like to see red at all. This is the so-called hard problem of consciousness, and its stubborn resistance to reduction suggests that awareness may not be just another emergent property of matter, but a fundamental aspect of the universe, as basic as space, time, mass, and charge. If this is true, then your existence as a conscious being is not a trivial side effect of evolution. It is the final, irreducible fact upon which all other facts depend. This has profound implications for how we think about death, the universe's fate, and the possibility of realities beyond the physical. If consciousness is fundamental, then it may not be annihilated when the physical structures that support it, your body, your brain, even the universe itself, dissolve. It might instead be transposed into another mode, one that we cannot currently conceive, just as a song can survive the destruction of a single instrument. If the melody exists in the deeper structure of music itself, this does not mean you, as you know yourself, will persist with memories and identity intact. But it could mean that the capacity for awareness, the bare isness of experience, is indestructible. From a certain perspective, the universe's entire history can be seen as a process that eventually allowed itself to become aware of its own existence, a chain of cause and effect leading from the formation of atoms to the birth of stars, to the emergence of life, to the moment you are reading this sentence and recognizing that you exist. In that sense, you are not just a bystander to the cosmos. You are its confirmation, its living proof. And yet, this leads to a paradox. If consciousness is the final evidence of reality, does that mean reality is subjective? Are there as many realities as there are conscious observers? Quantum mechanics complicates this further, with experiments suggesting that the outcome of certain events may not be fixed until they are observed, implying that the act of measurement, and by extension, awareness, plays a constitutive role in shaping what is real. Some interpretations of quantum theory, like the participatory anthropic principle, take this to the extreme, proposing that the universe's very structure is, in some sense, fine-tuned for the emergence of observers. In this view, consciousness is not an accidental passenger, but a central player in the cosmic drama. Others caution that while observation is necessary for measurement, it does not necessarily mean the universe depends on consciousness to exist. Only that consciousness is necessary for any claim of existence to be meaningful. But even the cautious view leaves you with a startling truth. Without awareness, there is no one to say, there is a universe. That is why your existence, the undeniable fact of awareness, stands as the final proof you are. In effect, the experiment's readout. Imagine then, a far future where the universe approaches heat death. When all stars are gone, black holes have evaporated, and space is a thin haze of low-energy particles. In such a cosmos, there might be no complex structures left to support the kind of consciousness we know. Does reality, in any meaningful sense, still exist at that point? If there is no awareness anywhere, the question becomes unanswerable, and perhaps meaningless. In that way, the end of consciousness could be, from any experiential standpoint, the end of reality itself. even if the physical processes of the universe continue in some sterile, unobserved form. Conversely, if awareness can persist or re-emerge in some form, then reality, in the only sense we can confirm it, continues as well. This suggests a radical symmetry. Reality gives rise to consciousness, and consciousness gives reality its proof. They are not separate pillars, but two aspects of the same phenomenon, each incomplete without the other. This also reframes how you think about your own life. Every moment you are aware, you are not just existing within reality, you are validating it. Your awareness is the universe checking in on itself, acknowledging its own presence. This is not mysticism, but a simple logical consequence of the fact that the only way to confirm that something exists is for it to be experienced. You may not control the vast machinery of galaxies or the deep laws of physics, but without the lens of your awareness, all of that might as well be unwitnessed potential, and this recognition can change how you see everything. If you are the proof, then every moment of awareness, even the quiet, ordinary ones, is not trivial but cosmically significant. You are not here merely to drift through an already established reality. You are part of the act of bringing it into evidence. And when the time comes for your personal awareness to dissolve, whether into nothingness or into some broader field of consciousness, that fact will not negate the proof you have already been. The universe was real because you experienced it. And in that sense, your existence will always remain as the final, unerasable evidence that reality was here. The recursive memory paradox, remembering a universe, remembering itself. What if the universe is not merely unfolding events across time, but is also in a strange and layered way remembering itself? Not as a single act of recollection, but as a recursive process, where each memory contains a memory of itself being remembered, spiraling endlessly inward like a hall of mirrors, in which every reflection holds yet another reflection, each one slightly altered by the act of seeing. The recursive memory paradox begins with the realization that memory, whether in a human brain, a computer, or a physical system, is never just a passive record. It is an active reconstruction. In neuroscience, when you recall something, you do not retrieve a perfect copy of an event. You rebuild it from stored patterns. And in doing so, you embed the act of recall into the memory itself. The next time you remember it, you are remembering not just the event, but the previous act of remembering, with all its distortions and biases layered in. Now imagine applying this principle to the entire universe. Every process in physics leaves an imprint. Gravitational waves ripple outward from massive events. Photons scatter with traces of where they've been. Quantum states entangle and carry correlations that persist across vast spans of space and time. The cosmos, in this sense, is constantly writing its own autobiography into the state of its matter, energy, and fields. But here's the twist. When any part of the universe interacts with another, when a particle absorbs a photon, when a star's light is captured by a planet's atmosphere, when your eyes take in the glow of a galaxy, the information from the past is not just stored, it is woven into a new state that now also contains a record of that storage. This means that the memory is no longer just about the original event. It also encodes the fact that the memory has been accessed. Just as a book with marginal notes reveals not only the text, but the reader's engagement with it. Over cosmic time, this becomes recursive. The universe contains a record of itself, and that record contains a record of the record, and so on, like a digital file endlessly resaved with the previous version embedded inside. At small scales, this recursion is buried in quantum correlations and thermodynamic traces. At large scales, it manifests in the layered structure of cosmic history, where each generation of stars carries the chemical signatures of the ones before. Each galaxy's shape reflects its history of mergers, and even the cosmic microwave background, the earliest visible photograph of the cosmos, has been reinterpreted, gravitationally lensed, and altered by billions of years of subsequent structure. So that what we see now is not the original image, but the original image, as remembered through the intervening universe. The paradox emerges because memory, in both cognitive and physical systems, is not static. It changes with each act of recall. In the human mind, this leads to the well-documented phenomenon that recalling a memory can make it less accurate over time. In the universe, the same principle could mean that the cosmic record is constantly rewritten by the very processes that access it. Photons bent by gravity, particles scattering off dust, observers measuring signals. The more the universe remembers itself, the further it may drift from the pristine original. Yet those drifts are themselves preserved, creating a deeper, more tangled memory. Eventually, you could reach a point where what is remembered is less about what originally happened, and more about the vast web of prior remembrances. A history of history, an echo of echoes. And here's the truly dizzying implication. If the universe is a closed system, then all acts of remembering, whether through physical interaction or conscious observation, are themselves part of the universe's state. Which means the universe is not just remembering events. It is remembering that it is remembering them. This feedback loop could, in theory, create self-reinforcing structures of information, patterns that persist, not because they are original truths, but because the act of recalling them is encoded again and again, making them ever harder to erase. In this way, the universe could preserve certain memories, far longer than the raw physical processes that created them would seem to allow, simply because those memories are embedded recursively in other memories. Now, consider what this means for us as observers. When you look at the night sky, you are not seeing the real Andromeda galaxy. You are seeing the light that left it 2.5 million years ago, which has been bent, scattered, and altered by intervening matter, then captured by your eyes and translated into neural signals. You are remembering Andromeda through the universe's own layered memory, and your observation becomes part of that memory for the future. In principle, a civilization billions of years from now could detect the faint traces of our telescope's observations in the altered states of the photons and particles we have already touched, reading in them not just the galaxy, but the fact that we once looked at it. This makes every act of perception an act of co-authorship in the cosmic archive. But it also raises an unsettling possibility. If memory is inherently recursive, then there may be no true original to recover. Every attempt to reconstruct the past, whether in a brain, in a fossil record, or in the cosmic background radiation, is reconstructing a reconstruction, an infinite regression where the past is always refracted through the lens of its prior recollections. In physics, this would mean that the initial conditions of the universe, the beginning, may be permanently obscured by the countless layers of its own self-memory. Even if we could, in theory, unwind all the interactions and correlations to their starting point, we would still be unwinding the universe's history of remembering that point, not the point itself. This is where the paradox cuts deepest. If the universe can only know itself through its own memories, and those memories are always altered by the act of remembering, then the universe can never have an unmediated knowledge of its own origin, and neither can we. The recursion becomes both the mechanism of preservation and the source of distortion. Yet perhaps this is not a flaw, but a feature in living systems. Recursive memory allows for self-awareness, the ability to not only store information, but to reflect on the fact of storing it. If something analogous operates at the cosmic scale, then the universe is not just a vast physical process, but, in a strange way, a self-reflective one. Each galaxy, each star, each conscious mind might be a node in a network, through which the universe experiences its own state. Not in real time, but through the endlessly folded layers of its self-memory. The truth of the universe, then, would not be a single fixed thing waiting to be uncovered, but the evolving sum of all its remembrances, a living archive whose contents are inseparable from the act of archiving. This changes how you might think about your own place in it. Your memories are part of the universe's memory, and your memories of remembering are part of its recursive loops. You are not outside the process looking in. You are a layer within it, as entangled with the past and future as any photon in a cosmic web. And if this recursion is truly infinite, If each memory contains the memory of itself being remembered, then in some profound sense, nothing is ever fully gone, because every layer still holds all the layers beneath it. The past is never just past. It is always present in the act of being remembered, even if that remembrance is imperfect. In this light, the universe may never truly forget itself, even if it can never fully know itself either. An eternal mind palace built of echoes, reflections, and the unending spiral of its own memory. Your existence as proof, consciousness as the final evidence of reality. What if the only undeniable proof that anything at all exists is the simple, irreducible fact that you are aware right now that no matter what science discovers about the origins of the universe, the structure of matter, or the fate of time, the most unshakable evidence for reality is not written in the stars, but in the raw immediacy of your own conscious experience. This idea that your awareness is the final evidence forces you to turn the searchlight of understanding inward, because while everything else in the cosmos can be doubted, simulated, or reinterpreted, the experience of being cannot be an illusion to the one having it. Even if the entire external world were a perfect simulation, even if your senses were feeding you a fabricated universe, the fact that you are experiencing anything at all would remain undeniable. Philosophers have circled this truth for centuries. From Descartes' cogito, ergo sum, to modern theories of consciousness. But most stop short of treating it as the foundational proof of reality itself. In physics, reality is typically defined in terms of measurable phenomena, but measurements require observers, and the act of observation is inseparable from awareness. This is not to say that consciousness creates the universe in the naive sense of mind over matter, but that the very recognition of a universe requires consciousness as its stage. Without an observer, existence might still unfold, but it could never be confirmed. You can imagine a universe without life, without matter, even without space as we know it. But you cannot meaningfully imagine a proof of its existence without some form of awareness to register it. This flips the scientific hierarchy on its head. Instead of consciousness being a late byproduct of cosmic evolution, it becomes the precondition for any claim about reality to hold meaning at all. Now consider what this implies for the deepest mysteries of existence. Physics seeks to describe the laws that govern the universe, but no set of laws can explain itself without presupposing that there is a mind capable of apprehending them. Even the most complete theory of everything would still be a structure of symbols and relationships, inert until interpreted by awareness. This is the invisible foundation beneath all scientific inquiry, the observer's undeniable presence. And here is where the idea grows more unsettling. If consciousness is the ultimate proof of reality, then what exactly is it? Neuroscience can correlate experiences with brain activity, but correlation is not identity. Knowing which neurons fire when you see the color red does not explain why there is something it is like to see red at all. This is the so-called hard problem of consciousness, and its stubborn resistance to reduction suggests that awareness may not be just another emergent property of matter, but a fundamental aspect of the universe, as basic as space, time, mass, and charge. If this is true, then your existence as a conscious being is not a trivial side effect of evolution. It is the final, irreducible fact upon which all other facts depend. This has profound implications for how we think about death, the universe's fate, and the possibility of realities beyond the physical. If consciousness is fundamental, then it may not be annihilated when the physical structures that support it, your body, your brain, even the universe itself, dissolve. It might instead be transposed into another mode, one that we cannot currently conceive, just as a song can survive the destruction of a single instrument. If the melody exists in the deeper structure of music itself, this does not mean you, as you know yourself, will persist with memories and identity intact, but it could mean that the capacity for awareness, the bare isness of experience, is indestructible. From a certain perspective, the universe's entire history can be seen as a process that eventually allowed itself to become aware of its own existence. A chain of cause and effect leading from the formation of atoms, to the birth of stars, to the emergence of life, to the moment you are reading this sentence and recognizing that you exist. In that sense, you are not just a bystander to the cosmos. You are its confirmation, its living proof. And yet, this leads to a paradox. If consciousness is the final evidence of reality, does that mean reality is subjective? Are there as many realities as there are conscious observers? Quantum mechanics complicates this further, with experiments suggesting that the outcome of certain events may not be fixed until they are observed, implying that the act of measurement, and by extension, awareness plays a constitutive role in shaping what is real. Some interpretations of quantum theory, like the participatory anthropic principle, take this to the extreme, proposing that the universe's very structure is, in some sense, fine-tuned for the emergence of observers. In this view, consciousness is not an accidental passenger, but a central player in the cosmic drama. Others caution that while observation is necessary for measurement, it does not necessarily mean the universe depends on consciousness to exist. Only that consciousness is necessary for any claim of existence to be meaningful. But even the cautious view leaves you with a startling truth. Without awareness, there is no one to say, there is a universe. That is why your existence, the undeniable fact of awareness, stands as the final proof you are. In effect, the experiment's readout. Imagine then, a far future where the universe approaches heat death. When all stars are gone, black holes have evaporated, and space is a thin haze of low-energy particles. In such a cosmos, there might be no complex structures left to support the kind of consciousness we know. Does reality, in any meaningful sense, still exist at that point? If there is no awareness anywhere, the question becomes unanswerable, and perhaps meaningless. In that way, the end of consciousness could be, from any experiential standpoint, the end of reality itself, even if the physical processes of the universe continue in some sterile, unobserved form. Conversely, if awareness can persist or re-emerge in some form, then reality, in the only sense we can confirm it, continues as well. This suggests a radical symmetry. Reality gives rise to consciousness, and consciousness gives reality its proof. They are not separate pillars, but two aspects of the same phenomenon, each incomplete without the other. This also reframes how you think about your own life. Every moment you are aware, you are not just existing within reality, you are validating it. Your awareness is the universe checking in on itself, acknowledging its own presence. This is not mysticism, but a simple logical consequence of the fact that the only way to confirm that something exists is for it to be experienced. You may not control the vast machinery of galaxies or the deep laws of physics, but without the lens of your awareness, all of that might as well be unwitnessed potential, and this recognition can change how you see everything. If you are the proof, then every moment of awareness, even the quiet, ordinary ones, is not trivial but cosmically significant. You are not here merely to drift through an already established reality. You are part of the act of bringing it into evidence. And when the time comes for your personal awareness to dissolve, whether into nothingness or into some broader field of consciousness, that fact will not negate the proof you have already been. The universe was real because you experienced it. And in that sense, your existence will always remain as the final, unerasable evidence that reality was here.